practicing would join us by now, but they still haven't joined us. Okay. All right. More information now. All right. But that's your resources from CompTIA on the Cert Master platform. Now you have the CompTIA website itself. CompTIA.org is information there. This is different than the platform site. Okay. This is information about the certifications there, CompTIA.org. And then on this site, right, they give you the certification options and, gives you breakdown. Here's the network certifications. So, Network Plus was their first networking certification, but they've evolved. They offer numerous other certifications, including a very particular Cisco one, if you see here. This is not this course, though, right? That's that particular Cisco one. But here, you're in the Network Plus, which is vendor neutral, right? Not vendor specific information. Could apply to any network there. But you hit to learn more, you get more information about this certification there. Okay. And it, gives you information about the certification. It tells you skills you learn. It gives you exam details. Again, the information presented are the exam objective topics that CompTIA wants candidates to know to be able to challenge their certification there. And we'll cover all those exam objective topics when we cover all 14 modules of information this week there. But here it shows you, they launched this one in 2024. Like I said, it's a, every 3-year cycle that they use there. So they say, next year they'll be renewing. The thing is, though, when you get certified from the point you get certified, then it's good for 3 years on the candidate end, once you get certified. But then after the 3 years, you have to decide how you will retain the certification there. And there's, methods of, retaking the next level of certification is one method of retaining it. But another approach is taking a higher certifications that usually renews lower certifications. When I say higher, it's kind of a hierarchy. And, Network Plus comes after A plus there. And then after the Network Plus, they said, Security Plus would be considered higher and so forth there. No, again, the keyword is recommended, Moet. And, recommendations there. This might be your first exposure to networking, and you don't have the recommended background. That's okay. You can still learn networking, right? Because this is the Network Plus entry level to the networking world and certification. You follow that mohit there. Obviously, if you had any practical ones, then it would help because then you would know the topics already presented, right? If you have practical experience there. If not, then a lot of topics will be new to you. That's the only fact. And but the A plus, and that's why I mentioned the IT side of things earlier, right? Because IT and this one fit hand. But yeah, continue what I said earlier. To retain certifications, you could take the new version, like 010 eventually will be out in 2027 there, and it will be active for 3 years. Or you could take a higher certification, like Security Plus is considered higher than Network Plus. If you take that, if you take higher certifications under the CompTIA line, it renews your lower ones. That's how you do it. And then the other thing they offer is continuing education program. You could search for that. It's a program that you have to pay for. But then CompTIA outlines, courses you could take that would apply continuing education credits, and you have to achieve X amount of credits before the 3 years to then retain your current certification. So that's another way to do it too. All right. Once you're certified. Now they do point out here, when you take the certification, they say number of questions, maximum 90. You have a mix of multiple choice performance-based questions there. You'll get more multiple choice questions than performance-based, but you'll definitely get performance-based questions. And performance-based questions are scenario-based questions, and they do take longer to answer because of that. It's not just selecting A, B, C, or D, right? So you got to account for that, and that's going to take more time to get through those. And they tend to give those up front in the beginning of the exam there. They won't give you as many. You might get 4, 5, 6, but they will take more time, to answer. And they give you 90 minutes. So yeah, you got to be time conscious there. You can't, run down the clock too long, especially on the performance-based questions there. Although usually you make up time on the multiple choice side, but I always advise people on the multiple choice side, a good pace would be at least 2 questions per minute would be a good pace on that side, maybe even 3, to make up for the time, because you're going to take up more time on the performance base up front there, from away from that 90 minutes. Because if you start after the performance base, if you start doing a minute per multiple choice, that would not be a good pace because that will, wind down your clock too much there in those 90 minutes there. And then they, right, so that's, exam details. They also mentioned these obtaining the exam objectives, which I'm going to show you in a moment. Practice questions. Well, you have, as long as you found that email and as long as you register yourself to the Cert Master site, platform site, you have all the practice questions you need. This one will give you like 10, but you got, in a sense, hundreds of those back in the CompTIA platform site, to gauge where you are on your knowledge retention of the topics there. But in terms of the exam objective document, which you obtain by providing your email, and I'll show you how that document looks. Because CompTIA doesn't make it a mystery of what they want a candidate to know. It's all listed here in their exam objective document there. Right? This is the N10009. And this document divides it by different domains. It gives you the same, type of information about the exam itself. 90 number question, potentially 90, multiple choice performance based, 90 minutes there. Their recommended experience there. Not everyone's going to have that there. which includes, right, some experience in IT networking field. But then they break it down by domains. And this particular one is 5 domains: networking concept domain, network implementation, operation security, and troubleshooting. And then they show you the percentages of, questions that stem from those domains there. But then they give you the breakdown of every domain and all the exam objective topics they expect the candidate to know to challenge their certification there. And each, domain is divided into subdomains there. As you see here, this is domain 1 topics that we're going to be covering as we covered all 14 modules of the course, including port references there. Right? And this is all domain 1, right? But these are all the exam objective topics they expect a candidate to know. I'm scrolling through. Domain 2 is network implementation topics they expect candidates to know. All right, so all this under that domain 2. Domain 3 is network operation topics. So everything I'm scrolling through here, CompTIA says this is what a candidate needs to know. You challenge our certification. This has come directly from CompTIA. This is their exam objective document there. This is not us, Global Knowledge, saying, oh, this is what CompTIA is telling candidates. You need to know to challenge our certifications there. All right, this is domain 3 topics we're going to cover this week. Network security as well, which is, the cybersecurity realm there. Cybersecurity and networking fit hand in hand there. You got to learn how to secure the network environment there, right, from breaches there. So security topics there. And then network troubleshooting topics as well that we will cover this week as we go through these 14 modules there. So this is to give you an insight of all the topics we're covering this week. Everything that I'm scrolling through, we are going to cover as a topic there. Now, because it is a lot of information to cover, I have to keep a good pace this week. I can't, in a sense, do it to the level where I, take so much time on just one topic. I have to pace myself and have a continuous pace throughout this week to be able to make, the 3 lessons a day that we're going to cover in the 8 hours format there, right? But it is a lot of information, plenty of information we're going to cover this week. Everything I just scrolled through, we literally going to cover in the 14 modules that we do this week, the 8-hour format. And then at the end of this assignment objective document is a list of acronyms. Yeah, they expect candidates to know acronyms. Acronyms could be listed in questions or in answers, and they won't spell out the acronym if it's in a question or answer on the actual exam. They expect a candidate to be familiar with the acronyms and what it represents there. Okay, that is also an objective. All right, so again, this document that I just covered gives you an insight of all the topics we're going to cover this week and the 14 modules of information there. So it's not going to be a light week of information. There's plenty to cover and plenty to talk about, and I have to keep a good pace to do it. Okay, all right. Let me close this document so that I'll make it available on the chat. But I got that right from their website where I was right here, right from this website. Let me just bring it over to the chat window on the Zoom side. Actually, just going to make it available on the chat window. Just got to retrieve it. There it goes. All right. And the website also gives you that same breakdown, by the way. What I just showed you in the exam objective document, the website shows you as well there, right? And the 5 domains of information there. Okay. But the document gives you the full breakdown of the domains and the subdomains within them there and the topics that CompTIA expect the candidates to know to change their certification. All right, but that gives you, the insight of what we're going to cover this week there. Okay, then the other thing I want to show you here. Now they mention performance-based questions, right? Yeah, performance-based questions are scenario-based. Now, the questions that CompTIA gives you in the platform site are multiple choice. They don't give you performance-based versions there, okay? CompTIA is very limited on what they provide in performance-based questions. I can tell you that right now. But here on their website, they give a reference to performance-based questions here on this site that CompTIA provides, okay? But this is it. What I'm showing you here is what they provide in terms of performance-based questions, insights there. And performance-based questions, again, you won't get as many as them as the multiple choice, but you will get them, and they tend to give them up front. But even if they give you, 5, 6 of them, it always takes longer because you have to, scenario-based, you have to do something to come up with the answer. It's not just picking A, B, C, or D there. It's a simulation there. It says, simulation approximation of environment or tools such as firewall, network diagram, terminal windows, and so forth. They give you one to try, but that's it. They're not going to give much on that end there. And, it gives you this scenario there, and it tells you what to do. It says, check the IP addresses and test the connectivity to CompTIA.org on each workstation. Use this information to ensure the access control list is properly configured to allow workstation access to internet. But the point is, they're telling you what you need to achieve, but you then got to have to know what to do to achieve it there. Like opening up a workstation and doing commands like ipconfig or ping and so forth. But you got to know how to do that there, right? You have to know how to be able to, accomplish what they want you to do to answer these scenario-based questions there. But it has to be off the top of your head. In other words, and I tell students, and that's quite different than a lab because a lab tells you what to do step by step, literally. Well, not necessarily all labs, but sometimes you'll have lab environments that tell you, oh, I do this, and that. And this scenario-based, How do you check IPs? You have to do commands like IP config, or how you check connectivity. You would have to know to do a command like ping. But that's the point. You would have to know to do that, right? To be able to use that information to be able to answer this type of question. So that's an every base. They also give you a video, watch a virtual PDQ. Videos are helpful too because they give you an insight how to navigate a performance-based questions by someone taking you through the video to do it. So it's always good to watch videos on someone navigating through performance-based questions and how they accomplish the question there, right? To get those insights there as well. All right, so that's what CompTIA provides on their website in terms of performance-based questions there. Again, the questions on the platform site are just multiple choice. They're not performance-based questions there. This is, what I'm showing you outside of that platform site that CompTIA provides to give you insights performance-based. There's other resources out there that you can use beyond the CompTIA. I'll give you more of that FYI come Friday at the at my wrap-up session there. Some other resource besides the CompTIA ones to give you further insights. But these are the insights you want because you don't want the certification to be the first time that you ever try a performance-based question or even solve the concept of performance-based questions. That would not be a good strategy or approach to that there. You need these types of insights. All right, so that's on the performance-based side there. Okay, other information I want to provide there. So the importance of the platform site. I gave you insight from the CompTIA website and the certification information there. Gave you an insight to performance-based question reference there. You saw the exam objective document. That shows you what we're going to cover this week. But then once you access your student guide, right? The student guide will give you access to all the 14 modules that we're going to cover. But this is the one where you have to enter the platform website, right? That I covered earlier to get your course PDF so that you could reference as I'll be presenting it with the PowerPoints. But CompTIA makes the PowerPoint available to me as an instructor presenting the course. I cannot share my PowerPoints with anyone. They're copyrighted to CompTIA. I'll be violating their copyright. If CompTIA wanted students to have a PowerPoint, they will provide them directly. If you don't see them, I have them because I'm the instructor there. But the information in your student guide is the same as the PowerPoint, just in a student guide format. As a matter of fact, I always tell students that sometimes there'll be information that's not in my PowerPoint or that's not in the CompTIA PowerPoint because they provide them, but it's in your student guide reference. If it's in your student guide reference, I'll still reference it because it's in your student guide side. It's not like I'm going to, skip information just because it's not in the PowerPoint. Okay. I'll just say, it's over on your student guide and you'll see it there. Okay. All right. So that's the course PDF, but you got to get into that platform website to get access to this course PDF and the 14 modules we're going to cover this week. Okay. Very important. Is anyone still working on that by chance? I'm hoping everyone at this point saw the email at this point and started and registered to the site there. Is anyone not registered to the site yet? Okay, good. All right, very good. That's a good sign there. All right. Okay, I think let's see. Oh, and then another thing is now you all came in through the MyGK portal. I'm going to flip back to my main window. I don't have access to the MyGK portal like you all do. You use the MyGK portal from my organization, right? Global Knowledge. And you use that portal to get into the virtual class. Ultimately, what it does, it launches the Zoom session, right? Because we're in a Zoom session. So what I tend to also do is I give the Zoom information as well. The reason I do that is kind of a backup plan because just in case for some reason the MyGK portal is not cooperating, one morning, I don't want to hold up the class because of that there. Because the other way you could get into the class is from the Zoom website. But when you go to the Zoom website, you will have to put in a meeting ID and passcode. And I'm going to provide that right now as a backup plan. Of course, this should not be shared outside of the class, but always use the MyGK portal, right? That's what we provide you to get into the class. But if for some reason that MyGK portal is not cooperating one morning, instead of you not being able to come into the class, then switch over to go to the Zoom directly, right? Zoom.us or however you have to access Zoom, and join a meeting and put in the meeting ID and passcode, and you should be able to get into the Zoom that way too to come into the class. So there should be no reason why we cannot start this class at 8:30 a.m. Eastern Standard Time sharp. Okay, and that's my expectation. But you keep using the MyGK portal to come to it, but now you have a plan B just in case, right? You should still be able to come in and be with me, right, at the start of the class. Okay. But then there's other things in that MyGK portal. Again, I don't have the ability to show you because I don't have access to it as a student. But what you would see there is all the various tiles, right, that come up in the MyGK portal. And, one of the tiles allow you into the virtual class. But then there's some other tiles there. This is like an example of it. This is not exactly it. This is a screenshot of it there, so it might look different for you. But, you eventually also have access to class recordings from there. This is the MyGK portal, right? From my organization, Global Knowledge. And the class recordings are not instantaneous, though. I can tell you that. From the time I end a class, it does take Zoom a while to process the recording there. Eventually, yes, it will be made available under that tile there. But it does take a couple of hours after the class for that to become available, right? Little FYI. That's available for review there. If you need to hear me say something again or topic again, you can use those recordings for that purpose there. Then there's a exam voucher, but that's eventually what you'll be able to request. But you usually can't request it on the first day of class there. It's be usually active after the first day. But then you will request it by sending an email, and then they will reply back with the voucher code and the instructions and how to redeem it. And the exam voucher is good for covering one take of the exam in terms of the cost there, right? Because the voucher doesn't give you unlimited tries there. Okay, it's good. It covers one cost because there is a cost for taking the certification there, and the voucher covers one of those costs there. The initial take. After that, if you had take it again, then it's your own cost to do that there, right? To do a retake. And then class evaluation, which, I will I'll remind you all about that on Friday there, right? At the conclusion of the class. All right, so that's on the Magic 8 portal side. All right, I think, oh, no, yeah. I do want to give you a preview also. There's the, in terms of the voucher and setting up the certification, it will eventually tell you of a website called Pearson View there. And I want to give you an insight to that. Yeah, because it's the Pearson View website that you will, set up an account. Normally, sometimes it does, because once you register for the platform site, normally it does a single sign-on type of scenario to get you into the CompTIA side because you would do the CompTIA portion of the Pearson View site in particular to be able to set up and schedule a CompTIA certification exam. Right? It says, continue to log in. Like normally, again, it does allow you to do a single sign-on there. Although people have set up accounts for themselves using their own personal email, and that's fine. You could do that there. But either way, once you log in, then you're able to schedule the certification. And, they have find a test center, find a test center on military base, if that's your scenario. But then the other version that's become very popular is online, testing online, through the internet there and, test anywhere, anytime, yeah, which is very flexible, but although they're very strict, I can tell you that right now. They're not going to leave you by yourself or anything. No, there's going to be a live proctor, and they have to observe you at all times. They have to see and hear you at all times. And there can be nothing around you, and they're very strict. They have to be, to keep the integrity of the certification, because any answers have to come from what's in your minds, and not, you're looking up answers and so forth. They're not going to let you do that. Okay, so right, but I've done it like that. It's worked out. I follow the rules. I had no issues there. Okay. I didn't get offended because so many rules and so forth. I understood that they have to keep the integrity of the exam and make sure no one's right trying to use answers during the online testing, a reference that has their answers. Okay? I didn't get offended. All right, so there you go. That's all the upfront information there. Terry says, your computers when I least I prefer in person, but the questions that have pops up with them can feel very annoying. If you feel a fluster, just take a breath and know it's just the show computers they have. Yeah. Oh, really? That was your experience there? You're talking about going to a test center there, Terry?
Yes, sir. I did my Security Plus and my CYSA Plus in Central Louisiana, and their computers still had the big old chunky monitors.
Oh boy.
Just
Yeah.
keep
Well,
that
I
in mind.
guess
Don't let
to
it
be
upset you if it's slow.
to be honest, like the times I went to a test center, I have numerous choices in my areas of New Jersey, and the ones I've attended, their computers were modern, to be quite honest. So I guess depends on the test center, I guess then,
And yeah,
what they're
I just
and
went
what they
to
got
private
equipped.
private
Yeah.
club, so it's
Yeah.
probably they just didn't want to invest in that area.
Oh, I got you. So you're probably limited to where you could go.
Yeah, it was either in the Central Louisiana area or I would have to go down to Baton Rouge or something to test in the computer.
Oh, I got you. So yeah, so maybe you want to look into that online version there. That's another choice there.
I just prefer in person because I got kids and
Oh,
stuff.
you do. Okay.
So try not to stay anywhere where it would be a problem.
I'm surprised to hear that though, that a test center will have equipment that's not up to modern.
And like
Yeah.
sometimes during my Security Plus, it timed out in the middle of the test. So I had to raise my hand and get him to come reset the test and get me back to where I
That's
was. Just
yeah.
don't let that fluster you if it does happen. It's not a big deal.
Yeah, yeah. But yeah, like I said, in my area of New Jersey, I have quite a few to pick from, and they're always pretty good. I go in, modern computer setups, and never had an issue. But yeah, I guess it depends your location and what's offered there. Yeah. But do keep in mind, online is another option now there. So it's worked out. You just got to install a browser locker. They make sure no one's in the room with you and so forth, and you can take it from anywhere, anytime. Yeah. All right. Okay, so yeah, that's all the upfront information for you all there, right? But that gives you an insight to how our week is going to play out. We're going to cover all those exam objective topics from those 5 domains of information I showed you in the 14 modules. We're going to do 3 modules a day and 2 on Friday. Okay, that's how we're going to do it. I'll give some time for practice questions. I can't give a lot though. Same thing for labs, because I got to use the majority of time for lecturing. I only have 8 hours with you all. So the majority of labs and questions you're going to have to do beyond the class, but that is the intent anyway. That's why CompTIA gives you those resources way beyond this class week for that very purpose there, to gauge where you are on your knowledge retention, and then you'll get some practice on the labs to give you some insights of networking, topics there. All right. All right, very good. I was hoping the other ones that are missing would join us by now, but they haven't. I don't know. Hopefully they join us soon there. The only thing is, once someone joins us that's late, I cannot ignore it. We'll have to stop and address them and make sure that they have their resources and so forth for the class and tell them, well, it started at 8:30 a.m. Eastern Standard Time. Sometimes people mix up the time zones. They come at their 8:30, but then it's already an hour into the class, so I've had that happen before. All right, so what I'm going to do is I'm going to set, before I start lecturing, I'm going to set a 10-minute break. I said I take 10-minute periodic breaks throughout the day, besides the 1 hour break that I give you at 12 noon. Again, the 12 noon is the set break, the periodic 10-minute breaks is throughout the day. So I'm going to set a counter for that. All right. All right, so 10-minute counter, break time. And then after that, I'm going to begin lecture. Again, today's objective, lesson 1, 2, and 3. Hopefully you all got into that platform site and you have your course PDFs ready to go, okay? I hope that's what I'm hoping at this point. All right, 10-minute break. Hello? James, you have a question? James, was that you? Oh, I guess I unmuted mistakenly. Okay. All right, as the clock starts to wind down, it was a 10-minute break. All right, so we're going to begin the lecture. Again, our objective for today is the first three lessons, 1, 2, and 3. So as I stated, I'll be presenting with the PowerPoints that CompTIA provides me as instructor. You should be following along with your course PDF reference, right? That has all the topics we're going to cover and the 14 modules or lessons we're going to cover this week there. All right, so module 1 begins us with explaining network topologies topics, and you will see each module is divided into different topic sections. Some modules have more topics, or some lessons have more topics to cover than others there. This particular lesson 1 has 3 topic sections to cover. So first, 1.1 topic is networking overview there. One thing my PowerPoint slide points out, when they show these references here, earlier I made available the exam objective document on the chat window. And, it goes by domain and subdomains. So this, it says this goes with exam objective topics 1.2 and 1.6. When you're looking at that exam objective document there, right? And the 5 domains of information it breaks down. So this is all part of domain 1, right? In particular, 1.2 and 1.6. Okay. That's how it breaks down. All right. And then this is the overview of the topics we're going to cover here. So a starting point here, they're mentioning networking concepts there. And they're referring to client server networks and peer-to-peer. Yeah, and the client server reference there is literally that. You have users on their client machines there, right? On their endpoint devices, communicating with server systems across the network, right? Connectivity there. So that becomes a client server environment. It says, it's one where some nodes, such as a PC, laptop, smartphones, users use different clients nowadays there. It says, and servers are more powerful computers that are implemented by organizations. Those servers could be internal on the local area network, or nowadays, right, could be accessed across the WAN to a remote system, including the cloud there. But yeah, client server is a very popular communications on the network there, right? Where you have the centralized server running server operating systems that are meant to allow concurrent clients to connect to them. And then those servers could share applications to those clients there. And that is preferred nowadays, especially like think of a scenario where you're collaborating with others on a project, and maybe you're all using the same file of information there. If you each person working on the project had their own individual files installed on their local client, you could still collaborate. But anytime you make changes to the file, you have to make sure that that change is synchronized to the other user's right file on their local client there. If not, then you will have all different information. But you see, if you set up a file server as an example, now you centralize things. So then you all access the same file from the file server, and anyone makes a change, all the other ones will witness that change instantly because you're all accessing the same file at that central point at the server. And that's just one example of what makes server, centralization, client server, a very popular implementation in network environments there. That centralized approach of managing applications and files and databases from the server and the client accessing that through the network connectivity. Right. So that's client server architecture. And then you have peer-to-peer version. And the described peer-to-peer says is one where each host acts as both client and server. Although they say server, that doesn't mean you have to run a server operating system on your local client. No, you can run the standard client OS like Windows 11. But in a peer-to-peer scenario, you're accessing another client and their resources that they're sharing to the network. So it's technically from one client to the other there. The server factor is just that they're sharing resources, right? So they're sharing that with other clients on the network, and the other clients could find them either by a host name or by IP address if they know that, and then connect to them to the network connectivity, and then access their shared resources, whether those are files or even hardware could be shared that way as well. So that's called a peer-to-peer environment there. I said this is peer-to-peer decentralized model. Yeah, because the client server, server centralized and the client access. So peer-to-peer is decentralized, right, from one client to the other. It says where provision, management, security of services and data distributed around the network. Yeah, because it's at the client level there. So you have to know, authentication credentials to access that particular client and their shared resources there. Has anyone ever had to use a peer-to-peer connection for any reason? Maybe you're sharing files with others, or others are sharing files with you, or maybe you share hardware with another client. Anyone has ever done that? You might have even done it through the internet, by the way, using phone Wi-Fi. Well, yeah, that's a type of scenario. That's more of setting up a hotspot type of. Yeah, you could see that as in a sense of peer-to-peer. That's kind of a hotspot scenario you're talking about, Mohit. You heard the term hotspot, right? You turn your client hotspot. But I'm talking more. Like I give you an example of how I've done it in the past. Before printers got popular to be attached to the network at my home environment, I had my printer in the past was connected directly to my desktop, right? But then what I did, I went into the Windows settings and I shared the printer out to the network. Uh, and then I went to my wife's laptop, and then I peered my desktop. Right? I found my desktop on the network, and then installed the printer that I share from my desktop on her laptop as a network printer. And it was a peer-to-peer type connection, and she was able to send print requests to my desktop that was attached to the computer, and then out came the printout. But that was a type of peer-to-peer type of scenario going on there. Everyone follow that concept? You could do the same thing with files. If I want to share a file with you out on the network, then I would, share that out. You could find me, right, by either by name or IP, and then pull that file and then bring it into your own, right, local system there. That's peer-to-peer. You might have done it. The reason, like Mohit, I emphasize hotspot because what you describe sharing, and I imagine you probably meant your cellular connection with others. That's a hotspot, they call that there, which is a topic under the mobile and wireless side there. But peer-to-peer is more about sharing your resources, period, with anyone else through the network connectivity there, whatever that resource is there. Maybe some of you have done that across the internet. There was a service that was started way back in the day that now I'm drawing a blank on the name, but it was people shared their music. Oh, Napster. People shared their music with others across the internet, and then you were able to peer their machine and whatever music they were sharing, you were able to play it right across the internet. In modern times, that's what a BitTorrent does. When you access a machine in a BitTorrent site, if you go to them, that's a peer-to-peer. They're sharing a resource to you across the internet there, and then you can access that resource from one client to the other. That's peer-to-peer. Okay. And some organizations may allow both, although peer-to-peer, come with risk because you got to make sure you secure each and every client that's sharing resources out on the network. With the client server, is a centralized approach, right? And the server sharing its application resources from that central point there. Yeah. All right, but continuing, the next reference, they mention appliances and the term appliances. It says networks make use of many type specialized platforms. It's unlike general purpose Windows or Mac OS, computers and servers and appliances, a computer with an operating system and software designed to perform a particular network role. And they give examples of appliances. A switch is considered appliance. A router on the network is an appliance to the network. A wireless access point that forwards data is an appliance. A firewall that provides protection, intrusion detection, is an appliance that's attached to the network, including load balancers and proxies. They all are appliances. They give specialized purpose on the network there. But they usually even to provide the network functionality and security, and they're considered appliances attached to the network there. Then you have the applications that are running on systems. As the nodes and links of networking infrastructure are deployed to run services. The services are share applications that allow the network to be useful there. Yeah, it could be file sharing or an email application that's set up on a server there to provide that particular service on the network there, or that application there. And again, usually through a central point like the client server scenario. Although you could run applications locally on your local clients, but it's very popular to run applications on a server, centralized point, right? And then the clients access that centralized application from that server. And then you have the various functions that are provided in the network. It says networks can be configured with additional properties to perform different functions. And they give an example. It says the security properties of a virtual private network, VPN. It says allows devices to join a local network from the internet. But that's its function, to provide remote, secure connectivity across the unsecured internet there. It says another example of a function providing quality of service functionality. It says allows optimization of a network to suit a particular time-sensitive application. Yeah, like quality of service becoming a function, time-sensitive packets that are traversing the network. They mentioned voice and video fits that category. Again, my introduction to networking when I was in the field was voice over IP, and I had to learn that fast. That voice over IP packets are time-sensitive. From the time they're created to the time that they reach their destination point, so they could be decoded, so they could hear your voice, has to happen at a very rapid pace there. And if you delay those type of time-sensitive packets, they use the term real-time communications, for example, happening right then and there. And voice over IP is real time. You're talking to someone at that very moment. That's different than email. Email is not real time. You could send someone an email, maybe they respond to you right away, or maybe they respond to you 2 days later. That's not real time. But voice over IP on video transmissions, it's happening at that moment there. And if you delay those packets, it's going to affect your quality of service of those transmissions there. So you got to make sure they're not delayed and provide proper quality of service mechanisms so that the network appliances know to give them prioritization on the network and not delay them going across the network, especially switches and especially routers. And routers should not delay time sensitive packets there. And there's methods that are used to ensure that to provide that type of quality of service for time sensitive transmissions across the network, like voice and video. Right? And that becomes a function that you're providing on the network, that quality of service. All right, next topic is network types. Network types. And in the network types, it mentions, network type refers primarily to its size and scope. The scope is how far you could reach there, right, to a resource out on the network there. And so they mentioned the different network types. They start us with a local area network, a LAN environment. It says it's confined to a single geographical location. Yeah, because even if you have a organization in a building with multiple floors, right, that they own, and each of those floors have their LANs, and each of those LANs are interconnected with the other LANs on a different floor, it's still a LAN within that building. It's still confined, right, to that building. And your LAN is your private network, your local area network there. And that's where you attach your appliances to the LAN, to the local network there. It uses endpoints, and then which are the nodes, and then the appliances like your switches, your routers for your internal use, right, and your internal private LAN there. But then we could and they mentioned there's different LANs environments, at least in your course PDF reference, not my slide. And they mentioned in the LAN category, you could have a Soho LAN. They mentioned Soho again. That's described in your PDF, not on my slide. Soho stands for small office, home office. It says business-oriented network, possibly use a centralized server in addition to client, but it's smaller network environments there. It says, but often still using a single internet router, switch, and access point. Right, Soho, small office, home office. Then they mention a SME environment for the LAN, the small and medium-sized enterprise. But anytime you hear that word enterprise is a organizational environment there. It says, the SME network supporting dozens of users. Such networks will use structured cabling and multiple switches and routers. And then you have the very large enterprise LANs. This is a larger network with hundreds or thousands of service clients. So such networks will require multiple enterprise class switches and routers to maintain performance. Yeah, because you wouldn't take a small office, home office router, which usually are, a combination switch router, and put that in a large enterprise environment. It won't be able to handle the load there. Right? You have enterprise level switches and routers with more CPU, more memory to handle the traffic that go through them there. And then they also mention a data center. And again, this is on your PDF. Remember what I said earlier, there'll be things not in my slide, but it's in your PDF, right? Then you have the data center LAN. And it says a network that hosts only servers and storage, not end user clients, right? In a data center environment there. Yeah, even before the cloud concept, we used data centers. My time in the field in telecom, we used to set up data centers for our telecommunications equipment, to provide services to our customers in an area. Now you fast forward, data centers are everywhere because, the cloud is ultimately a data center. When you hear the cloud, we're going to talk more about the cloud as we go along this week. Ultimately it's data centers that they're setting up there, right? Data centers are appearing everywhere. You hear a lot about AI, right? Those AIs are working on server systems. We're in a data center environment that hosted usually as a cloud platform there, right? So yeah, it's data centers have their lands too. Then to extend our reach or scope, we connect the LAN out to the WAN side. The WAN is wide area network. And to describe the WAN, it says WANs is a network of networks connected by long distance links there. Yeah, during my time in the field, I worked for an organization, MCI WorldCom. They no longer exist. Unfortunate things happen. But we used to provide WAN circuits for our customers, literally. When our customers wanted to connect their locations together, but they operated throughout the United States in different states, and we provided WAN circuits. During my time in the field, what was popular for that, I used to install a lot of T1s and PRIs, primary interface, as WAN services. There's an evolution of WAN services now, many other type of circuits there. But that extends your reach to a remote network when you go across the WAN circuit there, right, to a remote LAN to access their resources there. The internet is in the WAN category. The internet is the world's largest WAN, right? It spans throughout the world there. That is a WAN technology, the internet there, right? Wide area network. Just connect long distance. Yeah, you can, and then you connect your LAN and you route out to the WAN and vice versa there. All right, so that was the network types. Next is the reference of network topology now. And they describe a topology. It says describe the physical or logical structure of a network in terms of nodes and links there. But yeah, you have the physical side of that. It says describe the placement of nodes on the networks and how they are connected by transmission medium. And then you have the logical side of topology. It says describe the flow of the data moving across the network. There it says, given different physical network topologies, if in each case the nodes can send messages to one another, the logical topology is the same. It says different physical implementations directly connected via cable versus connect to the same switch achieve the same logical layout there. But yeah, the logical again describes the flow of the data that the packets across the network. The physical is a physical implementation of the network connectivity there, right, to create a physical topology. And they're describing different topologies. They start off with a simple point-to-point topology reference. And so simple type topology, a single link is established between two nodes, from one point to the other. And that could go across long distances too, like across the WAN, connect 2 points together across the WAN. Or yes, it could be within the local area network as well, right? From one point to the other. So that's, point to point connection there. And it says, because only two devices share the connection, they guarantee a level of bandwidth, right? From one point to the other, point to point connection there. They also mentioned duplexing factor there. It says physical point-to-point topologies using different media types for half duplex and full duplex. Yeah, when they say half duplex means you could transmit and receive one at a time. They call that half duplex. So if you're transmitting, you're not receiving. Excuse me for a second. I got to do something here. All right, so they call that, half duplex communication. You transmit, you can't receive. If you're receiving, you can't transmit there. Excuse me for a second. I got to do something to my Zoom. My Zoom is not behaving itself. I'm gonna stop the share for a quick moment, and then I'm gonna reshare. I'm trying to clear up an issue I'm having here. Hold on. Let's see if this clears it up now. Yeah, there you go. So I could annotate before, now I can. All right, so yeah, that's half duplex. Half duplex means you could only send and receive one at a time. Send that and receive that one at a time. You can't do it at the same time. But if something operates in a point-to-point full duplex, that means you could transmit and receive data at the same time there. And that's, most preferred in modern networks that you could transmit and receive that at the same time instead of waiting one at a time there. Half duplex is kind of origins, kind of legacy now, although it still could be used, but, the preference is full duplex, transmit and receive that at the exact same time. And also not collide, the signal on the medium on the wire there in full duplex mode, because half duplex signals could collide as you're transmitting data, if you start receiving those signals will collide with each other and cause a collision, they call that. Then we don't want that. All right, but that's the point to point from one point to the other there, right? That's one topology. Another topology they mentioned is star topology, which is very popular in use in modern networking there. And yeah, star topology could be on a local area network, or it could be across a WAN as well, a wide area network there. And they describe the star topology. It says each endpoint node is connected to a central forwarding appliance, such as a switch or a router. And that's why they call it star topology. You have a central point, and the nodes are connected to the endpoint nodes, like user systems are connected to that central point there. Yeah, like in a local area network. Back in the day, we used to create a star topology with a hub for Ethernet. Uh, Ethernet is MIAX control. And we started off with a hub for Ethernet. The hub became the central point, and we connected all the users' endpoint devices, like their desktops or laptops, to the hub ports. Right? That created a star topology. The issue is, though, if that central point goes down, then all the communications in that section, right, goes down there. But if it's like one individual device might have a problem, that doesn't necessarily mean the other devices can't communicate through the central device like a hub. But fast forward to modern times, we eventually replace hub with switches. So switches is the most common appliance for star topology, modern LAN networks there. And for your wired connectivity, and the switch becomes a central point that you connect, right, all your users' endpoint devices to there, or star topology. Now that's on the LAN side, but you could do it on the WAN too. During my time in the field, we used to set up for customers, it was called hub and spoke, and which is a star topology scenario too, because they, not to be confused with the hub that I just mentioned. The hub and spoke for the WAN was you designated a hub site, a central site, like maybe a central headquarters became the hub site. But then the organization had branch offices, right? Branch locations. And then we connected the branch locations to the central hub site, like headquarters, through WAN circuits. And they were able, one branch was able to communicate with another branch through the hub, right? They would send their packets, their data to the hub. The hub would then route it over to another branch there. And we call that hub and spoke out on the WAN. That became a star topology scenario out on the WAN side there. So yeah, the star topology could be used on the LAN side and on the WAN side with hub and spoke on the WAN. Okay, that's the start. Now, next type of topology is a mesh topology. Mesh topology is for resiliency and communication there. They try to avoid SPOF conditions, SPOF. Anyone know what that means? SPOF? SPOF? Have I heard that before? We don't want a SPOF, right? Single point of failure. We don't want single points of failure there. Yeah, because consider that point-to-point connection, right? If it's from one point to the other and something happened to that connection, you lose communications, right? Well, a mesh, in a sense, consists of point-to-points, but it's multiple points-to-points to create resiliency in a mesh topology. If you look at this, right? Because think about it. You have this location point to point to this one, but then also has a point to point to this one, and also has a point to point to this one and this one. But then they connect to each other to other points, right? So there's this meshing going on. That provides resiliency and voice of spots. If this connection between one and two has a problem, but can they still communicate? Yeah, because one could go over to three, that goes over to two. It could go over to four, that goes over to two. It could go over to six, that goes over to two. It could go over to five, that goes over. So yeah, that creates resiliency in communication. But it would take a lot of points to go down in the mesh topology to lose communication, and that's a major outage if that happens there. If you lose that many connections there at once, then you can't communicate there. Now, there's a little formula that they express here that you need to know this formula reference here, okay? Over here, see this little formula there? It says in a fully connected mesh, each node has a point-to-point link with every other node. This requires exponentially more links as nodes are added. But that little formula, n multiply in the parentheses n minus 1 divided by 2 there. Yeah, that formula is used to tell you the amount of it says the number of links required for a full, amount of links. It says the number of links required for a full mesh is expressed as n in parentheses n minus 1 divided by 2. It says where n is the number of nodes. So it says, for example, a network of just 4 nodes. So 4 will be in place of the ends, right? 4 nodes will require 6 links. So 4 nodes require 6 links, where 40 nodes will require 780 links there. Yeah, if you plug, let's do the 4, right? 4 nodes. So it would be 4 multiply, right? And then in the parentheses there, n minus 1, and then divided by 2. The 4 will also be here. There. Because, right, they said the 4 nodes will require 6 links. So how they got that answer? Well, you got to follow PEMDAS in math. We describe that as PEMDAS. Remember PEMDAS from back in the days in math class? Yeah, that's the order of operations in math. And because parentheses come first there, right? And then exponents, multiplication, division, addition, and subtraction. That was called PEMDAS. That's the order of operation in math, how you do things there. Anybody remember that PEMDAS from math days? Anybody? Nobody remember that? I'm the only one that remember PEMDAS. All right, okay. I see a thumbs up there. Math. Who said it was going to be math in the class? It's not hard math, though. You just follow the. Oh, really? Is it? Interesting. It is? I thought everyone followed PEMDAS. All right. That's interesting to hear that. All right. But yeah, parentheses are done first. And because you do parentheses first, 4 minus 1 is 3, right? So you do that first. Then you do the multiplication. Oh, okay. Interesting. What does that spell out? Now you got me on that. Bob Mass. Bob Mass. You got me on that. You got me on that one, Bob Mass. All right. So you do the parentheses first there. Oh, I got you. Just a different terminologies they use. I got you. Oh, interesting. Okay, wait. Now you see you put me onto something now. Now I'm going to keep that in mind for the Canada side. All right, bomb mass. All right. Now I see it. Oh, bed mass. Okay, bed mass too. Hey, I learned that too there. I hadn't heard. I've had Canadian students before. No one let me on that one on the Canada side. All right, very good. But it's the same concept though, right? Just different terminology. But yeah, so we do the parentheses first, right? 4 - 1 is 3. Then the multiplication, 4 × 3 is 12. And then the division divided by 2. And that gives you, right, the 6 links answer, right, for the amount of nodes. So yeah, once you know the nodes, you plug it in, do a PEMDAS or BEDDAS or BOB dot, excuse me, bed mass or Bob mass, and then you get the answer there. Yeah. And then you could do a partial mesh. I said partial mesh networks I often prefer, and a partial mesh. Yeah, not everything is interconnected, everything, but it still promotes, trying to avoid, as single points of failure conditions, right, where one link goes down and you can't communicate at all. You want to avoid that. All right, so that's mesh topology. There's other topologies in your student guide reference. It's not in my slide, so I just bring it up in the student guide side because they're there. Right after the mesh and partial mesh and the order of operations the formula there, right? Plug in the amount of nodes, you get the amount of links you need. But then they mentioned some legacy topologies in your student guide reference. There's a bus topology. Yeah, we used to set a bus topology back in the day. In technique used to do it. It says consists of a trunk cable with nodes either inserted directly into the trunk or tap into a trunk using offshoot cabling there. But yeah, we used to even use bus topologies and on the LAN side back in the day. We used to have, they called them, we used to use coaxial cabling and T connectors. T connectors was like an in and an out, and you connected your systems that way down the bus line. And there was a terminator that you put at the end of the bus line to absorb the signal that was traveling across, from one system to the other across the bus. Big issues with the bus though, uh, if there was any break in any area of the bus line, it stopped all the communications literally because the signal had to go to each and every one and to reach the terminators. So if that was severed, it brought down the whole bus. But that's legacy. That was back in the day. We use a bus topology there. Then another one they mentioned, which is considered legacy now too, is ring. So yeah, this is an example of a bus, right? Daisy, like a daisy chain, right? One from another. I mentioned T connectors, yeah, because there was an in and out with the coaxial cabling and the origins there down the bus line. That's old school. That's way back. Then there's a ring topology. Now, ring topology, IBM, which I worked for IBM back when, was a big proponent to ring topology technology for its time. Ring topology was a popular media access control before Ethernet took over there. And it says, ring topology connects neighboring nodes until they form a ring or circle there. So the signal travels in one direction around the ring, with each node on the network acting as a repeater to send the signal to the next device. In the ring topology there. One popular implementation of the ring topology. By the way, it's not my resolution. It looks like that in the student guide. So it's not your eyes. If you're trying to put on your glasses, like why is that looking blurry? It's the slide itself. Okay. First time I saw it, I was like, what is going on? And then I was like, oh, it's the slide. But yeah, the ring topology. We used to do a multi-station access unit actually. So it kind of looked like a star topology. For its time, it was called a multi-station access unit. It wasn't a hub or a switch, though. It was called a multi-station access unit. And then we used to connect the the nodes to that, the endpoint systems. Now, physically, it looked like a physical star topology when we did that. But logically, the way the data flow was a ring topology within itself. The data flow from one neighbor node to the other in a circuit of motion on the ring there. And the popular implementation, so remember, because there's a physical topology and logical topology. So physical, it looked like a star topology. Logically, in terms of the data flow, it acted like a ring. Right, so yeah, the very popular implementation was token ring. IBM promoted that a lot. It was token ring because logical token was passed by the multi-station action unit to one node at a time. And the node that possessed it, or the endpoint device that possessed the logical token, could transmit its data to a neighbor node down the ring, but only one at a time. And the reason they did that is to avoid what we call collisions. Collisions on the network when different signals meet on the wire and collide with each other. And we don't want that. So token ring try to avoid collisions by only allowing one device to transmit its data on the ring one at a time. The logic there is only one thing transmitting at a time. There's nothing else to collide with. It can't collide with itself, right? And then that will avoid collisions there. So that was the token ring. In the WAN side, they don't mention it. There's a WAN implementation as well that uses, ring topology. It's called SONET, Synchronous Optical Network. They're not mentioning that. I'm just giving you an FYI on the WAN side. It was called Synchronous Optical Network, which, involved fiber optics. And it was always deployed as a dual ring on the WAN side for resiliency. If one portion of the ring was affected, as long as the other portion is not affected, you could still communicate. But it applies a ring topology on the WAN technology side there. Yeah, during my time in the field, we used to input into the sonic ring because we used to convert the electrical signal from the customer to light because the sonic ring is fiber optics and that would travel as light to the destination point at a long distance across the sonic ring. That was ring topology on the WAN side, token ring on the LAN side. That's the ring topology. They consider legacy now, but yeah, that's ring topologies. Although Sonic, yeah, could still be used on the WAN, but there's other WAN technologies that replace it now. So, all right, so that's for the various topologies. All right, so that completes lesson 1.1. Lesson 1.2 is going to go into the OSI model. It's a 7-layer model reference that we're going to cover here. Let me set a, not that I'm going to break after every topic because that would be too much, but I am going to set another 10-minute break for now, and then we'll get into 1.2, okay? All right, I was 10-minute break. Okay, so next up we have lesson 1.2 is the Open System Interconnect Model Concepts, which is a seven-layer model reference developed by the ISO International Standards Organization there. All right, so we're going to reference the seven layer, and there's also there's another model called the TCP/IP model, but here they emphasize the OSI model. So when it comes to the OSI, they give us a little background reference. It says the International Organization for Standardization (ISO) developed the Open System Interconnection (OSI) reference model. It says for more understanding of how components in a network system work. It says it does this by separating the functions of hardware and software components into seven discrete layers there. Yeah, and in terms of hardware and software, you need both to communicate on networks there. The top layers deal with the software factor of communicating on networks there, right? The top layer software, where the bottom layers deal with the hardware. Okay, and that is a distinction they make, especially when troubleshooting things and using the OSI model as a troubleshooting reference there. You have a hardware related issue, a software related issue, right? Software looking at the top layers, hardware looking at the bottom layers functionality there. But each of these layers have different functions to allow you, right, to communicate on the network, and it's a layer approach there. And they're going to describe each of these layers as we go along. Now they mentioned data encapsulation, de-encapsulation there. Yeah, because there's different protocols that operate at the different layers. And each of those layers, put their information, their header information for addressing, and also carry a payload for data there. But because different protocols operating in different layers, they all get encapsulated to create they call it a PDU, protocol data unit there. But then each of those headers are individualized depending on the protocol that's operating on a particular layer there. Now they mention addressing. It says addressing describing where data message should go. And that's done at the header portion. It says at each OSI model layer, there are different mechanisms for identifying nodes and rules for how they send and receive messages there. And then there's the encapsulation that happens, as describing how data message should be packaged for transmission. Encapsulation is like an envelope for a letter, with the distinction that each layer requires its own envelope there. Yeah, because each layer in different protocols have its own header information. Like Ethernet has its header, IP has a different header, TCP, UDP adds their headers there, right? And they're all encapsulated together there. But they identify the different layers that those protocols are operating in there. It's almost like an assembly line there. And they're showing, the header information being added. The data, you can also call the data the payload as well. That's a term that you will hear in networking too. Payload is data there. But yeah, the header information from the different protocols operating at the different layers there. All encapsulated together to create what they call a PDU, protocol data unit, that is transported to recipient end. The recipient end does the de-encapsulation, processing all the individual headers of the individual protocols operating at the different layers there. But all the network devices will see all the headers. But as an example, a switch will be interested in the Ethernet header, in the Ethernet frame, because a switch forwards by MAC addresses, where a router will be interested in the IP header, which operates at a different layer, because routers route by logical address IPs instead of MAC addresses there. Right? But all the devices see all the encapsulated headers from all the different protocols operating in different layers. How they use it depends on the device there. Maybe a firewall, blocks by logical port. So it looks at the TCP header to determine, whether it should block a port or not, depending on that header, right? Which is operating at a particular layer. Right? So that's the encapsulation, de-encapsulation. Different headers and different payloads of the protocols operate in different layers. Now they start off describing the actual layers, starting with the bottom layer one, which is also known as the physical layer. It says that the OSI model is defined as layer one. It says the physical layer is responsible for transmission receipt of signals that represent bits of data. When they say bits of data, bits are either 0 or 1. Matter of fact, in the previous, you see that pattern at the bottom right? Zeros and ones. That's also the binary. Because, yeah, that's how data is transmitted. Ultimately, that's how processors process data. To a processor, CPU, data is either a 1 value on or 0 off. And that's how the data is transmitted across the physical media at patterns of zeros and ones. If you think about that, you could do that electrically. You could say electricity is there, 1. Electricity is not there, close to the ground, 0. Or you can even do that through light, right? Because fiber optics is a physical layer reference, physical medium. You could say light is there, 1, or light is not there, 0. Even wireless is referenced at the physical layer. But you can send a radio frequency that's, this frequency modulated in a certain way represents the 1, and modulated a different way, amplitude modulation, inverse modulation, and then that represents the 0 value going across the air there. Right? But that's, where the physical media is referenced at the physical layer there. And then the bits, the zeros and ones, the data transmitted across that physical medium there. But they mention, the cabling involved at the physical layer. It says the samples include copper cabling, which is still very popular. Fiber optics is very popular. It says cable medium can also be described as bonded media. But then they also mentioned the wireless. The wireless is mentioned in your PDF reference on my slide. Well, what I mentioned earlier too. It says uses the free space between nodes such as microwave radio. It says wireless media can also be described as unbonded media there. Then they refer to a physical topology that's used, right? It says the layout of nodes and links as a status transmission. Well, we just talked about the physical topology area. Like a star topology, for example, right, will be a physical topology. Then they also mentioned the physical interface. It says mechanical specification for the network medium. It says for cable media, this means the construction of the cable, the interface connector form factor, and the number of functions of pins or connector. It says for wireless media, it also means radio transceivers and antennas that are used. Like a physical interface, you have your NIC card, network interface card. You could attach your twisted pair cable, category cable to it. The category cabling has an RJ45 connector that accommodates the 4 pairs or eight pins there, right? That's, the physical interface factor. Then you have, they mentioned signaling. It says the process of transmitting, receiving, and coded data over the network. It says modulation scheme describes how electrical, light, and radio signal represents the bits, the patterns of the zeros and ones that ultimately represent the data that they're transporting across the data, across the network there. It said, timing and synchronization scheme ensures send and receivers identify groups of signals as a chunk or frame of data. Right? That's then processed by their receiving device's CPU as patterns of zeros and ones. And then the devices that operate the physical layer, they mention a transceiver that transmits and receives, right? This is part of the network interface, sends and receives signals over the network medium. And then you have a repeater device also at the physical layer. So a device that amplifies an electronic signal to extend the maximum reliable distance. Yeah, as signals travel across the medium, like electrical signals, they weaken over time. We call that weakening. There's a term called attenuation. It describes the weakening of the signal as it travels further out the media there. And if it hasn't reached its destination point, then you need repeaters to boost that again so that could continue traveling, right? And repeat that signal and boost it to a stronger signal until it reaches its destination point there, right? So that's repeaters there. Even in fiber optics, which is transmitting light, we need repeaters after X amount of distance, right? Or it could be miles or kilometers, and then it has to be repeated the light because it weakens too much the longer it travels across the medium there. And then they mentioned hub, which is the legacy device that I mentioned earlier. That was the first device that we used for Ethernet star topology back in the day, a hub. It says multi-port repeater deploy as a central point of connection for nodes. Anyone ever seen a hub back in the day? The physical hubs for star topologies back in the day, way back in the day? I don't know if anyone's ever seen that. Then you have a media converter. When I started back when, some places were still using hubs, believe it or not, way back when. Now fast forward, you don't see that on networks. And then you have media converter. It's a device that converts one media signal to a type to another. Yeah, because you might have to go from electrical signal to light, light to electrical, right? That's called media conversion when you do that. Right, so that's all happening at layer one, physical layer. Then you have the layer two is next. It's known as the data link layer. It says, boy, y'all made me feel, oh, I'm the only one that saw a hub back in the day, but I'm feeling old now. So you have the data link layer. And what it does is it's responsible for transferring data between nodes on the same logical segment. It says at the data link layer, it says segment is one where all nodes can send traffic to one another using hardware addresses. When they say hardware addresses, that's the physical address, also known as the media access control address, MAC addresses there, because that's referenced at layer two. The data link layer refers to the media access control, MAC. For example, in modern networking, a popular media access control that operates at layer two is Ethernet. Ethernet is a media access control that operates at layer two. And devices could talk strictly from one MAC address to the other if no routing is involved. That's actually what would be the contents of an Ethernet frame. That's reference to layer two. And switches, for example, operate at layer two. And switches will identify devices' MAC addresses, their physical addresses, when they're connected to a switch port. A switch will learn that. We'll hear more about switches later today. And, an Ethernet frame, a switch looks at the destination MAC and will forward the Ethernet frame according to a particular device's MAC address in the destination MAC of an Ethernet frame, which is a physical address which is embedded in a device's NIC card, network interface card. They mentioned the NIC card is what attaches you, right, to the physical network there. But inside that is a physical address, a MAC address there. And that's, the data link layer allowing devices to communicate through those physical addresses from one to the other there at layer two, where no, routing is needed there at that point. Before switches, we used to install bridges on the networks. The bridge was the first device that learned devices' MAC addresses that would plug in into its ports as well to forward a particular Ethernet frame to a particular network, what they call collision domain, so that the device can receive it. And then also wireless ACK point operating there, because similar concepts, wireless ACK point will forward also according to the MAC address of the device's wireless NIC card, and the device receives it right from that, referencing the Ethernet frame destination MAC. So that's happening at the layer two, data link layer. It says the data link layer also performs encapsulation and organizes a stream of bits arriving from the physical layer, layer one, into structured units called frames. Yeah, because we'll call it, for example, an Ethernet frame. It says each frame contains a network layer packet as its payload, which is the data. So the data link layer adds control information to the payload in the forms of header fields. Yeah, like Ethernet has a header for source MAC and destination MAC there, right? That's used at that layer, at the data link layer. All right, for that local communication from one device to the other there. But we'll describe more of the media access control function, especially Ethernet as an example. As we go along in the course, you'll hear more about Ethernet as we go along. Ethernet is not the only media access control that operates at layer two, but it's the most widely utilized one, especially on the LAN, and now it even extends out to the WAN. Okay, one device communicates with another device from one MAC address to the other, and the switch will forward Ethernet frames according to those MAC addresses at layer two there. All right, then you have the network layer three that's used. It says this layer is responsible for moving data around a network known as an inner network there. Yeah, so when you're no longer communicating with a local device on the local network, because if you're communicating with a local device on a local network and no routing is needed, you could just, communicate from one MAC to the other, which is the previous data link layer. But now if you could have to communicate with another device on a different network segment, whether it be a subnet within the LAN or going across the WAN to a remote network, then you will have to go to layer three routing. And routing is done through the logical addresses. The IP addresses are used for routing. They mentioned the appliance the router. Yeah, the routers will look at IP addresses to determine the route destination and route you to that destination there. Routers are not the only ones that can route by IP address. There's also, although they don't mention it uh, here, there is also a layer 3 switch to do it. Layer 3 switches are popular nowadays. The switch itself could do its own routing within the switch itself because layer 2 switches can't do routing. At the data link layer, because that's just from one MAC to the other. That's not routing through the logical address of IP, but layer 3 switch could do that routing from one logical IP segment to the other there, besides the router doing it. FYI, that's popular now. And it says, basic firewall operates to enforce access control. Yeah, they mentioned that because firewalls can filter by IP is why they're mentioning that there. You could decide which IPs are allowed in and which ones are blocked through a firewall there too. Right? That's happening at layer 3 with the logical address of IPs. Right, from one IP to the other. We'll be hearing more about IP addressing definitely by tomorrow. We'll go to that topic of IP addressing for IP version 4 and 6 tomorrow, which is the layer 3 reference, right? And we'll be talking more about routers as well as we go along in this course, right? And they route by logical addressing there. All right, then we have the layer 4 reference, which is known as the transport layer. And what occurs there, right? They mentioned the end-to-end communications that occur, host to host there. Yeah, we have, transport layer protocols that operate at layer 4. And it says, end-to-end host to host layers identify each type of network application by assigning a logical port. Yeah, the two popular transport layer protocols that operate at layer 4 is transmission control protocol, user datagram protocol, right? Are the two popular ones. And whether it be TCP and UDP in their headers, they will identify ultimately the application data segments or datagrams that they're transporting by a logical port number in their reference. We'll hear more about TCP UDP as we go along this course this week. But there's a series of port ranges. Some are in the well-known port ranges or register port ranges or even an ephemeral port temporary. For example, if TCP is transporting hypertext transfer protocol in its TCP header, it will reference TCP port 80 because that's the well-known port for HTTP. So it's transporting HTTP data segments there. If UDP is transporting domain name system, DNS, datagrams, then it would identify in its header as well-known port 53, because that is the port reference for domain name system there. So, they always identify the protocol they're transporting or the application, which is actually the layer 7, but TCP and UDP are responsible for transporting their datagrams or data segments because the protocol can't do that itself. TCP, UDP does that at layer 4 there, transporting their data to the destination port. Now it's transporting and tracking, well, TCP tracks it, UDP just sends it, but they don't do the routing though. That's why you always hear people say TCP IP. TCP is keeping track of transporting the data segments, but IP at layer 3 is needed to route you to the network to a device that's going to receive those data segments that TCP or UDP is transporting there at layer 4 there. And it says devices operate there, multi-layer switches, they operate higher than layer 2 and security appliance. Yeah, same thing, because a firewall could look at those logical ports. And according to its rules, it could say, oh, you told me to block these, to allow these ports like 80, 443, 53, but then block all the other ports. By doing that, you're controlling which applications protocols are allowed into your network and which ones are not. Right. So yeah, that's very popular for security appliance like a firewall to do that. Okay, that's happening at layer 4, transport layer. All right, next up is the layer, the up now. And here, they're giving us examples of some logical ports, 84, 45, 25, 50. Right, those are logical port references that ultimately relate back to applications protocols at layer 7 there, whether they be well-known ports or registered ports. Identifies what they're transporting. All right, now remember the lower layers deal mainly with hardware, the upper layers with software there. So now they're getting into the layer 5. It says most application protocols require exchange of multiple messages between the client and the service. This exchange of such a sequence of messages is called a session or dialogue. And so layer 5, tracks those sessions or dialogues that have been started in the network. It says represents functions that administer the process, establishing a dialogue, managing data transfers, and then ending or tearing them down. Right. So layer 5 responsible for that, tracking the sessions that are started. Yeah, it could track sessions by socket reference. A socket is a combination of IP and port to identify your session at that moment there. Or you could track sections with cookie references there, right, to track your particular session there. I just use the term socket equals IP and port. Right, to identify that particular session there. Or yeah, track things with a cookie reference or WinSockets, right? Track your sessions there that have been established or be established there. And then there's the layer 6, which is presentation layer. It says transport data between the format required for the network and the format required for the application, depending on the application that's being used. They give an example. It says the presentation layer is used for character set conversion, such as between American Standard Code for information exchange, ASCII, and Unicode, presenting it in the format that the application can interpret correctly there. Other things that happen at the presentation layer, if you're providing encryption, secure communication encryptions, things like secure socket layer, and continuation TLS will be referenced at the presentation there because the data will be presented in its encrypted format, right? Once encrypted is your ciphertext format, once encryption is applied. So that will be referenced at layer 6 as well, besides the data formatting. Also data compression, you can reduce the size of the data before sending it. That will be also referenced at layer 6, presented in a compressed format. And then final layer 7, application layer, This is at the top of the OSI application layer protocol. Doesn't encapsulate any other protocols or provide services. This application layer provide an interface for the software programs or network hosts that have a static communication channel to the lower layer protocols there. Yeah, like you could open up your browser, and yes, you could say your browser is an application, but truly what's being used within the browser is the application. Like if you're talking from a client to a web server, the application will be, for example, HTTPS is the application at layer 7 there, which is it's a TCP, well-known port 443, by the way. And because it's HTTPS at the presentation layer, it's going to apply either SSL or TLS, right, to encrypt it, to make it secure at the presentation layer. And then the session will be tracked. Your socket will be established at that point, IP and port to identify your particular session. Okay. Then the transport layer, because it's HTTPS in particular, it will be TCP involved transporting it, and it would identify its logical port as 443 for HTTPS, right? As transporting its data segments. And at the network layer, even if, like when you go out to a website, yeah, you may put a domain name, of course, but you're not being routed by domain name. Ultimately, in the background, the domain name is being matched to an address record or even quadruple A record, which is an IP address you're going to be routed to. So ultimately, routing happens by logical address, right? Logical IP address. Right? Even if you put in domain name, it will be matched to a logical address you'll be routed to. You don't route by name, you route by IP address. Okay? And then at layer 2, your MAC address will be identified. Your device has a MAC address, and it will be communicating with another MAC address. Like in the case of routing, it will be communicating with the MAC address of the router that is going to send its routing request to. And then that takes over from there and continues the routing right to the destination point. But yeah, but the MAC addresses will be referenced, and that will be referenced in the Ethernet frame. Ethernet is the most widely used media access control that operates at layer 2. And then finally, your data will be placed on the physical layer, whatever that is. It could be copper cabling that your bits go out, right? The zeros and ones could be on copper cabling, maybe fiber optics, maybe across the air, radio frequency there, right? That will happen at the physical layer there. Maybe even media conversion, because you may start as an electrical signal, but then be converted to light, fiber optics, to transport you to your destination point there. Hopefully, though, we're not seeing any hubs on modern networks. That would not be good. We should be seeing switches there. But yeah, they're just reminding us that hubs operate at layer 1 there. Yeah, so. All right, but yeah, that's the layer approach. And encapsulation happens, different headers from the different layers and protocols operating encapsulated together to form a protocol data unit. And you could actually see layering happening. I'll give you a little insight to that. This tool here is very popular protocol analyzer. It's called Wireshark, and it captures packets on the network there or frames on the network. And I can open up an individual frame, and we can see some of the layers, not all 7. We can see the top layer 1. It says packets 70 bytes on the wired. That's layer 1. That's physical layer. So, 70 bytes capture or 560 bits. Yeah, you got to think in bits and bytes format. It's 8 bits equals 1 byte, by the way, and then 4 bits equals a nibble. Right, bits and bytes on the wire. Then layer 2 is showing you, the MAC addresses from one source MAC talking to a destination MAC. That's the layer 2. That's the Ethernet is a media access control, recognizing the device's MAC addresses, right, from the device's NIC cards, from the physical address from one MAC to the other. And then the layer 3 shows you the IPs, the logical address involved, right, from one source IP communicating with a destination IP. That's the layer 3 logical addressing happening, right, routing from one network to the other there. Or even if you're not doing routing, it's still identified layer 3 from one IP to the other there. And then the layer 4 is the transport layer, where TCP is transporting this HTTP, right? And it's identifying as a source port 80, which is the well-known port for HTTP transported to this destination port. Those ports identify protocols, applications ultimately there. The TCP is responsible for transporting those data segments there, and IP does the routing. So you can see the layer happening. It is layer that's happening there, and different protocols adding their header information, right? Operating at different layers there. All right, so that completes 1.2. We will be getting into 1.3 now. I'm not going to set another break because, our extended break is coming up very soon. We're going to be taking an hour. Like I said, if I keep breaking after every topic, that'll be too many breaks. It'll be like 5 hours of breaks, because 10 minutes add up, right? 5, 10 minutes, and 50 minutes already. So I'm going to keep going to lesson 1.3, right? Which is SOHO networks, small office, home office networks there. Okay. All right. But that was the 7-layer OSI model reference from topic 2. All right. Now going into lesson 1.3 is SOHO networks is the topic here. Small office, home office. Okay. And they're relating, SOHO references and also relating it to the OSI model there. They start with a SOHO router, small office, home office router. Yeah, SOHO routers are integrated type of devices, appliances there, because they have routing functionality, and they usually have built-in switch within them there they give you LAN and WAN connectivity all from one unit there, right? That's the small office, home office type of router there. They mentioned, on those routers you have the physical layer connections, the layer 1s on a SOHO router. They refer to the RJ45 ports. Yeah, that's for the popular twisted pair connection that you could put onto those routers there if you want a wire connection there. Or also operating at layer 1 is the radio transmissions, right? Because those SOHO routers tend to give you the wireless, act as a wireless access point for wireless clients there to communicate, right? Transmit and receive the wireless signal there. And then also modems with modulate so it connects to your internet service provider. Yeah, because it's giving you the LAN connectivity, but then it routes you out to the WAN side, wide area network, like connecting you to your internet circuit there, right? And they show a picture of that. So you have the RJ45 for your LAN connections there. That's physical layer. They have the radio transmission for wireless there. That's also physical layer. And then they give you, that WAN port, which is physical connection to connect you up to your internet service provider circuit there, right? To take you out to the WAN there, right? Or operating at layer one. But then also the router provides you a data link layer functionality, layer two. And because it's mentioning Ethernet, right? It has a built-in Ethernet switch where you connect your RJ45, but then it's going to identify your device's MAC address, right? That's connected to those ports so that it can forward Ethernet frames according to those MAC addresses there. Remember, the MAC addresses are embedded into your device's NIC card. Your router will identify that MAC address, whether you're communicating with it wirelessly, because your wireless NIC card has a MAC address, and your wired NIC card has a MAC address too. They each have individual MAC addresses. They will both be identified, right, at layer two by that Soho router, and Ethernet frames will be forwarded to your devices through those MAC addresses there. Right, so that's happening at layer two. Right, as the device is plugged in, it'll identify the device's MAC address. Again, you could, for example, see MAC address references. If I do an IP config command / all, I can see all my Ethernet adapters, and each of the Ethernet adapters has their own physical or MAC address there. And your router will identify that, right? See physical address AC91A12A26EC. So I'm connected with a wire connection to my home router. My home router identifies my laptop that way through this physical address. And if it gets an Ethernet frame with that destination, it will forward, right, to my device's MAC address so I can receive that Ethernet frame and the data that comes with it there. Okay? That's happening at the layer two. Okay, now going from the layer two reference to the layer three, because then routing occurs, right, through IP to the logical address there. But also, those Soho routers tend to do DHCP. That's pretty common, dynamic host conversion protocol, where they assign you the logical address configuration from the router side. Remember, this is a Soho environment, right? Small office, home office there. Now, usually in Soho, they don't tend to create subnets on their LAN. So usually then it's just communicating from one MAC to the other. But then once you have to talk to a remote network, then yes, it's going to route you out to the WAN side to send you out to your ISP. And then your ISP continues the routing to the destination network point there. Now, what I said earlier, even if you put a domain name in your browser, in the background, domain name system is going to resolve that domain name to an IP address. So ultimately, you will be routed by IP address to the destination network or site. I would send you out to the WAN for that purpose. Oops, sorry. And then, right, so yeah, the logical addresses find your internal LAN that are assigned to DHCP, but then it'll route you out to the WAN side, right, to a remote network destination through your ISP there. And then here it mentions the layer four transport layer and application layer seven there. It mentions network security. It says allowing and preventing devices, users, and services from using network. Yeah, these routers tend to have basic, firewall functionality built into them where you can set up rules and determine what you want to allow and what you want to block. It says firewalls can be configured with rules specifying behavior of each port. Remember those ports that are referenced in the TCP or UDP header ultimately relate to an application, like port 80 is HTTP, 443 is HTTPS, right? And so forth. But you can determine which ports you want to allow in, which ultimately determines which applications you want to allow in. If you don't allow a port in, then that application related to that port is blocked, right, by the basic firewall functionality of a Soho router there. But you write those rules to do that. If you know how to go into your router settings to create those rules in the firewall functionality of it. And that's called basic packet filtering when you do that, by the way. And then, connecting you out to the internet, which is the WAN side, right? The wide area network version there, which extends your scope, your reach to remote networks there. And they mention, yeah, different, WAN or internet services as your internet access facilitated via public switch telephone network, your internet service provider. But there's organizations that will form to standardize the implementation of the internet. One such, well, they mentioned two, IANA and the Internet Assigned Numbers Authority. Yeah, and IANA controls, it says manage allocation of IP addresses and maintenance of top level domains. It says, and when they mean IP addresses, they're talking about the WAN side, they're talking about the internet side. It says currently run by the Internet Corporation for Assigned Names and Numbers, ICANN. Because IANA allocates addresses to regional registries that then allocate them to local registries or internet service provider. Yeah, because the internet is divided by different regions of the world, and there's different regional registries. Like in North America, our regional registry is ARIN, American Registry of Internet Numbers there. But then you have other parts of the world. You have one registry for Asia, for Latin America, for Africa, and so forth there. But they all get their IP allocations from IANA. To avoid an IP conflict on the internet, no two regions get the same IP ranges. But that's why we could exactly know what region of the world you're coming from by IP. If you're showing your real IP and not masking it, we could say, oh yeah, this IP is allocated to North America or Latin America or Asia and so forth there. And people use that also for content filtering too. May want to block IPs for certain regions and so forth, especially if you're not doing business with that region and so forth. That's pretty common. But it's all controlled by ANA. That's type of allocations to the regional registries. And then there's the IETF, Internet Engineering Task Force. It says focus on solutions for internet problems and adoption of new standards. And they publish requests for comments, RFCs. Yeah, if you want to know how any networking protocol or service operates there, you reference this RC, and they're maintained by the Internet Engineering Task Force. Yeah, like if I want to know how HTTP operates in details, I will reference this RC. So if I do a HTTP request for comment, and it leads me to the Internet Engineering Task Force data center site, and it gives me, RC 2616 particularly would give me the full details of hypertext transfer protocol and its operations there. The reason they call it request for comment because there's a consortium of different organizations that will review RCs. Especially when something is intended to become a standard in networking, an RC is created right away. And then the consortium of organizations review the RC and test what's referenced in the RC and comment back their results of that testing there, or any suggestions they have and so forth. And that's why they call them RCs, request for comments there. Right, maintained by the IETF, Internet Engineering Task Force. Yeah, these are the organizations that maintain the standardization of lands and the WANs. Okay? There's others besides these, but they mentioned these two in particular. All right, next, another topic. Now, this gets a preview of binary. They mentioned hexadecimal. Yeah, binary is the bits, zeros and the ones there. No, it's base 2. Remember, that is ultimately transported as patterns of zeros and ones. But yeah, knowing binary conversions is vital as well, especially to understand. Eventually, we're going to get into IP addressing by tomorrow there. And so this is a preview reference of that topic that we're going to get into more details of IP addressing tomorrow. But yeah, binary does play an important role in understanding even IP addressing and subnetting. But this is an 8-bit binary chart. The base is 2 and increases exponentially, like, from the far right, which is the least significant bit, 2 to the 0. Any base to the 0 exponent, it could be base 10, base 16, which is hexadecimal base 16, is 1 mathematically. But then, 2 to the 2 is 2, 2 to the, 2 to the 1 is 2, 2 to the 2 exponent, exponential math. Because if you see 2 to the 3, right? If you just did 2 times 3, you would get the wrong answer. It's 2 times 2 times 2. That's exponential, right? The base is increasing exponentially amongst itself, right? 3 times over. And then, it's just multiples of 2s from then on. 8 times 2, another 2 is 16. 16 times 2 is 32. 32 times 2 is 64. Add another, multiply another 2 to 64 is 128. And they stop there because it's 8 bits. And 8 bits equals 1. What did I say about that earlier? 8 bits equals 1. What?
Byte.
Right. 8 bits equal 1 byte. Very good. And we stop at that on purpose, 1 byte. Where 4 bits is a nibble there. Yeah, but binary conversions there. We're going to be, covering that more there. You have a binary pattern. Like if I populate a binary pattern here, right? If you want to convert it to decimal, all you got to do is add up where the ones are to convert it to decimal. Right? So this is a binary pattern. If I want to convert that to decimal, I just add up where the ones are. So the 1 is under 128, the 1 is under 4, the 1 is under 2, and the 1 is under 1. If I add a 128, 4 plus 2 plus 1, I get my decimal value. Who could give me that? 128 plus 4 plus 2 plus 1 equals what? Just simply add them up. Who could tell me? Come on, don't be shy on me here. It's not hard math. There we go. Yeah, 135. Yeah. 128 plus 4 plus 2 plus 1. Yeah. 135. That's it. Only Gideon was brave enough to come up with that answer. Come on. I hope other people thought of that answer too. It's just simple adding. That's all it is. There's no trigonometry here, right? Just simply add where the ones are, and that gives you your decimal, okay? The opposite is a subtraction approach there. I'll give a reference to that on the chat there. I'll put this 8-bit binary chart on the chat too, though. Oh, it's open. Let me close it. I'll give a reference going the other way. Yeah, decimal binary. It still uses the 8-bit binary chart, but it does a subtraction approach instead there, which I just created on the chat level. But yeah, we have to discuss binary, especially when we get into subnetting tomorrow, and you'll see why during the subnetting topic tomorrow. Right, it's a preview reference to that. But then they also mentioned hexadecimal. Hexadecimal used in networking base 16 there. And where do we see hexadecimal reference? Well, MAC addresses. MAC addresses are written in hexadecimal format, right? The base 16 format. Where the base is 16 instead of 2, but it's still increased exponentially. But if you look at the MAC address reference, that's hexadecimal, base 16. Notice how they're paired up together. See that? AC and then 9, 1. Those are hexadecimal. In hexadecimal, it goes 0 through 9, but then 10, 11, 12, 13, 14, 15, they stop at 15, is the letters A, B, C, D, E, and F, right? They don't show the numbers. They show for 10 through 15 is A, B, C, D, and F. For 0 through 9, they show those numbers, but it's base 16, not base 10, right? 0 through 9, and then A, B, C, D, E, and F there. But notice how they paired them together in the MAC address and the physical address. They do that on purpose because if you convert each hexadecimal to binary, it creates a 4-bit binary pattern. Each hexadecimal creates 4-bit binary. And just to give you an insight on that, what I'm showing you now is not referenced in the student guide. I'm just giving you an insight, further insight there. Let me bring back the 8-bit binary chart. In the 8-bit binary chart, to convert any hexadecimal to binary, all you need is 4 bits. And the 4 bits you need is right there, 8, 4, 2, and 1. That's it. Because if you add up 8 plus 4 plus 2 plus 1, what does it add up to? Who could tell me? 8 plus 4 plus 2 plus 1 adds up to what? 15, right? And that's the highest in hexadecimal. F is 15. You don't go higher than 15. F is 15 there. So to convert any hexadecimal to binary is really simple. If you consider A equals 10, right? A is the value of 10. Remember 10, right? 10, 11, 12, 13, 14, 15 is A, B, C, D, E, and F. If you convert 10 to binary, all you got to say is what adds up to 10 from these bits, 8, 4, 2, 1. What adds up to 10? Right? 8 and 2, right? 8 and 2 adds up to 10. So you turn those on with the binary. 1, 0, 1, 0. There you go. That's the binary of hexadecimal A. 1010. 8 plus 2 is 10. That's it. I just converted it. That's it. The reason I'm bringing this up is why they paired them together in a MAC address, because each converts to a 4-bit binary. The first hexadecimal is 4-bit, the second hexadecimal 4-bit. Together is 8 bits, and 8 bits equals 1 byte. So they're pairing them together because 4 bits, 8 bits together is a byte. So it's a byte, 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 byte. You got to think in bits and bytes, right? 8 bits equals 1 byte. You got to think in bits and bytes. 4 bits equals a nibble, right? So convert A and C. That's 4 bits in binary. That's a byte. So you could say a MAC address is made up. If you're talking bytes, you could say 6 bytes. If you're talking bits, it will be 48 bits, right? Because 6 times 8 is 48 bits. Right? You got to think in bits and bytes, bits and bytes. But they purposely write MAC addresses in hexadecimal base 16 format, and they pair them together to equal a byte when you consider the binary conversions. Okay. And also, IP version 6 is written in hexadecimal format too. That's the other. Besides MAC addresses, if you look carefully, there's an IP version 6 reference right here. Uh, it's called link local IP version 6. You see the format? Look, it's hexadecimal base 16 also. So yeah, I'm just giving you an insight where you see base 16 in networking. MAC addresses are written in hexadecimal. Um, IP version 6 is written in hexadecimal format there. Even in Wireshark in the bottom, if you look carefully at the bottom, gives you a hexadecimal dump of the values in hexadecimal format. There, yeah, hexadecimal is used in networking, base 16, and that's where you'll see it. All right, let's see. So that was the base 16 there. And they're showing you a chart here too, right? They're showing you the decimal, the hexadecimal, and the binary. I just showed you on how to convert it there. Okay. Now use that 8-bit binary chart, but to convert hexadecimal to binary, you only need 4 bits, A421. Right? That's all you need, A421. Right? What adds up to A4, right? To the hexadecimal, which relates to the decimal value. Okay. Like an F, right? It's 4 ones because if you add 8 plus 4 plus 2 plus 1 is 15. Right? That's it. Using that 8-bit chart. 4 bits at the end. All right. So that's some math there. Yeah, there's some math involved with this course. It's not complicated math, but yeah, it's needed math. So how many of you have been through binary before? Anyone? Anyone? Binary? The 8-bit binary chart plays important. No one's been through binary? Okay. That's okay. Mohit has been through binary. Only Mohit? I'm surprised. Okay, that's fine. Not me. Okay, James. Well, that's the first time, right, James? You're cool with it though? The 8-bit binary chart? Right. Zeros and ones there ultimately, which is data, it's ultimately zeros and ones. Base 2 increasing exponentially. All right, lesson 1.4 gets into troubleshooting a methodology topic here. Okay. Actually, let me do a 10-minute break. I know our extended break's coming, but let me do 10 minutes because I just went through math. I give you a little break. Okay. It wasn't hard math, though. It's not hard math. Just adding, subtracting stuff. All right, 10-minute break and we'll continue. Again, yeah, I'll do periodic breaks. I can't do too many though because they do add up, right? Because I give 10 minutes, especially. Yeah, 5 of those is already an hour, taken away from the other hour. So can't do too many. All right. Okay, oh, that was the break period. Continue now. All right, we reached lesson 1.4 or topic D, which is CompTIA's troubleshooting methodology reference there. And here, an outline of the troubleshooting methodology. But yeah, CompTIA expresses different steps of troubleshooting. Here, there, 7 steps. They refer to identify the problem, and they're going to reiterate these steps again. Once you identify the problem, is establish a theory of probable cause of the problem. Then you test the theory to determine the cause. Then you establish a plan of action to resolve the problem, identify potential effects, implement solution, or escalate as necessary. Then you verify full system functionality, implement preventive measures applicable. And then the 7th and final step is document findings, actions, outcomes, and lessons learned throughout the process there. All right, so that's the 7 steps in the order they take in the CompTIA troubleshooting methodology. But they reiterate these steps again, starting with step number 1 is to identify the problem. And within that step, you need to gather information about the problem there. And they mention it says identify the location of the scope of the problem. In other words, how many are affected by it. It says, scope means the area of number of systems affected. So this is useful in 2 ways. First, a problem that's a small scope might not be a priority in relation to other incidents. So secondary, establishing the scope can help to identify the source of the problem there, right? So more people infected, individual infected there. Also, in the process of identifying the problem and gathering information, says check system documentation, such as installation and maintenance logs for useful information there, like if this problem occurred again previously, before, and so forth. It says check recent job logs or consult on any technicians who might have worked on the system recently, who might be working on some related issue. It says use vendor support sites, base and forums. Yeah, because it might be a problem that has been seen before, maybe already addressed on a vendor's forum there, like Cisco and so forth there. Also, part of identifying the problem is questioning the users there, right? That report it. You can use open questions to question users. It says invite someone to explain in their own words. It says what is the problem or what happens when you try to switch the computer on there. But they have to give you more explanation there. They can't just give you a simple, yes no answer. If you just want a simple yes or no answer, then you use closed questions to do that, right? It says invite a yes or no answer. It says, can you see any text on the screen, or what does the error message say? It says closed questions can be used to drill down into the nature of the problem and guide a user towards giving you information that is useful there. Right, so asking a question to users, identify the problem. And then also part of the process is identify a problem, the symptoms, right, for that particular problem that's occurring there. And part of that process to identify symptoms and also to try to duplicate the problem. Yeah, I used to do that myself when I was in the field. I especially used to go to the user that reported the problem and say, okay, do it in front of me while I'm here, to see it happen while I was there and so forth, duplicate it. But they give you an outline in that process to identify the symptoms. It says make a physical inspection, look for something out of the ordinary, check system logs or diagnostic software information, duplicate the problem on the user system or a test system there. It says you would need to try to follow the same steps as a user. But that's why I used to literally go to the user and have them do it in front of me if that was a scenario and I was there and so forth there. And then also determine if anything changed. Yeah, change could have caused the problem there. And question behind that is, did it ever work? It says, hopefully your users will answer that question truthfully, right? Did it work? It says, because the correct answer is important. 2 different approaches. If the system worked before 9 a.m., you must ask what happened at 9 a.m. to make it not work. It says the system never worked, though. Then you're not looking for something that stopped working, but something which has never worked. And that might be a difference in error. That might change into a move, add, and change type of order instead of a trouble scenario there. And then also it says, what has changed since it was last working? It says the change that caused the problem might not be obvious, as maybe the window cleaners were in the building, one of them tripped over a cable. Now the user can't log in. You're implying that it pulled it out from the wall jack and so on. So yeah, again, hopefully you could identify, right, probably the potential cause of the problem by referencing, right, did it ever work and what has changed since the last work there. And then you might end up with a scenario that says multiple problems happening concurrently at the same time there. And they might be related, they might not be there. It says if the problems do not seem to be related, it says treat each issue as a separate case, a different trouble ticket there, not related to the other there. It says it may also be the case that user reports 2 different problems at the same time. It says often preceded by while you're on the line, sort of statements there, right? And then you identify that there's multiple problems occurring concurrently there. But again, it might be a related issue, it might be separate issues, right? It says treat each issue as a separate case there, separate case and report a ticket. All right, so that's all part of step 1 to identify the problem there. Step 2 is establish a theory of probable cause of the problem, right? And again, this is the 7 steps in the CompTIA troubleshooting methodology. And that step number 2, establish a theory of probable cause, they're referencing the OSI model, right? The 7-layer model we just reviewed earlier. Remember, the top layers of the model refer to software. You might consider as a software-related issue, but the bottom layers, right, layer 1, 2, 3, are hardware-related, right? Depending on what you think is the cause of the problem. A software-related issue, a hardware-related issue depends whether you start on the top, which is software of the OSI model, the bottom, which is hardware of the OSI model. They also mention an approach, uh, divide and conquer, where you start with the layer you think is the most probable cause. They call that divide and conquer. Maybe you start at layer 4, and if you think it's more of a software related issue, you go up, right, to the top layers. If you think a hardware related issue from there, you go down to the bottom layers there. And also in the process of, establishing a third probable cause, I mentioned, question the obvious. Is step through what should happen, identify the point in which there is a failure error. So this approach can quickly identify obvious oversights, like network cable not being plugged in. Let's methodically prove the functionality of each component sequence, as this approach is more time consuming, but may be necessary for difficult problems there, right? And establishing a theory of probable cause there. All right, so that was all part of step number two, establishing a theory of probable cause using the OSI model reference to help determine if it's a software-related issue, hardware-related issue, and divide and conquer approach as well. And then step number three in the process is test the theory to determine the cause there, right? Is step number three in the process there. It says develop and test a new theory. It says by questioning the obvious, by using one or more methodological diagnostic approaches, hopefully you have gathered enough data to come to initial theory about the probable causes. Remember that you might be wrong though, without jumping to conclusions, set out to prove or disprove your suspicions by using your troubleshooting skills and two steps. Also, part of the factor is that you might need to escalate things. When I was in the field, that used to happen to me. Sometimes I got into something that I tried everything that I know to try, and I still haven't encountered what could be the cause of the problem or the resolution. And so we used to have be able to call into our upper level support team to be able to help us out to resolve things further there. That's the escalation process. Or if you consider that maybe the problem is covered under warranty, that's another factor. So the problem falls under the warranty. So, you contact the vendor that on it that has warranty to help provide the solution. Or another factor is the scope of the problem. Is very large or solution requires some major reconfiguration network. Or maybe the customer becomes difficult, abusive, or demands help on unsupported items there. And yeah, I remember, when I was in the field, uh, I was trying to troubleshoot this problem that was happening. It was on the telecommunication side on a phone system, BBS. And it got to the point where they literally had to fly someone in to address the problem. It started with a phone call first. And even the support team that was helping me remotely with trying to check all kinds of things. And yeah, they say, it looks like to be a software glitch issue, but this is going to require someone to come there and look at the software itself and the code itself to try to resolve it. And that's what they did at that time. They ended up flying someone in to be on site to literally look at the code and so forth, and they had to resolve it that way. But that's all part of the escalation process there, right? To determine the theory of the probable cause there. And then they mention, alternatives for escalations. It says, senior staff, knowledge experts, subject matter experts, technical staff, developers, programmers, administrators you can consult. So suppliers and manufacturers and other support contractors and consultants there. Right. So that's all part of step three to test the theory to determine the cause there. Step four is establish a plan of action there, right, to implement the solution there. Depending on the trouble, it could be a repair type of scenario. It says you need to determine whether the cost of repair and time taken to reconfigure something makes this the best option. It could be replacing things. So often this is a more expensive, maybe time consuming if it's not if a part's not available. So there might also be an opportunity to upgrade the device or software. Or if it's a low impacting problem, then you could accept. It says not all problems are critical. If neither repair nor replace cost effective, it may be a best idea to find a workaround or documentation move on. As long as it's not high impacting there, and you can find a workaround there. Also part of that process there, when it says assess the cost and the time required to apply your plan of action and consider potential effects on the rest of the systems. And yeah, especially dependencies of things. You're working on one could affect another. Got to factor that in as well. All right, so that's also part of step number four of establish a plan of action. Step number five is implement the solution there. And it says you implement the solution directly. It says reverting to a known good configuration. If that's the fix for the problem happening. Because yeah, maybe a change was made and caused the issue and reverting back right to previous configuration. At least you get you back to normal again, right before the issue happened there. But then, it says anything you're implementing in terms of solution, you got to follow a proper change management. Yeah, because it depends on the implementation solution. It could be impacting to the organization there. Because yeah, it might be the type of problem that they're not fully impacted and down, but applying the solution maybe require system downtime and restarts and so forth. So you might have to, of course, manage that with the customer and what's the time slot we could do this because we have to bring things down, apply. And when I was in the field, I used to do that all the time. I used to tell the customer if I can't do it now, then what time will be ideal? Maybe you have to come back after hours, overtime, and so forth like that, and apply the solution there. That's less impacting to them. And they also, they say here, escalate the problem to senior personnel. It says when you do not have authorization, implement solution. Then. Well, yeah, again, this is all part of step five, implement solution. Especially if you got to tell the customer, what's needed and so forth. You might want to involve senior management to discuss that with the customer and such. There. All right, so that's part of step five, implement solution. Step number six is verify the solution did in fact work out there, right? That it resolved the issue. It says validate the solution, fix, report problem, validate that the system continue to function. My approach when I was in the field for that was I would go to the people that had to solve the problem, report problem, and try it now, and do it now, right? And have them be satisfied that yeah, the solution is fixed. I mean, the problem is fixed there, right? Solution worked there, no longer having an issue there. It says obtain customers' acceptance, eliminate factors that might cause the problem. Yeah, depending on the nature of the problem, if you could apply preventive measures there. Maybe someone, did kick out a cable, maybe because it wasn't dressed properly and so forth and out of the way and things. Whatever has to be implemented to try to prevent a reoccurrence of the same problem. And that's all part of step six, verify the solution. And then step number seven, the final step is document your findings and actions and outcomes. It says within a ticket system, yeah, organizations have that because that's going to help organizations because sometimes it could be a repeat problem, not necessarily on the same customer, but maybe a different customer. And having that information is extremely helpful there because they say, this sounds similar to a previous problem we had with the same symptoms, and this is what we did to resolve that previous problem. So probably it's the same solution there. When I was in the field, I used to do that for myself. Remember, I was the type of person that I had different customers. I wasn't supporting one particular organization, right? I was working for an organization that provided the service, telecom services and so forth to customers. So I had numerous customers when I was in the field. And I personally, besides, closing out tickets property, and when I say property, not like, oh, I fixed it and that's it, you got to give detailed information and what you did and fix it. But I used to keep my own journal of that too for myself because it was helpful for myself. Because like I said, maybe down the road, same problem. So, this problem seems familiar. Let me look at something. Oh yeah, I had the same problem and here was the solution and so forth. So yeah, it's very helpful. The organization should have that on their end too, through their ticketing systems and be able to look right and see if the problem has occurred, what was the fix, and so forth there, right? You close it up properly, document everything. All right, so that was the 7 steps in the CompTIA troubleshooting methodology there, right? And the steps and the order they're taken and what happens in each of the steps there. Okay? All right, so with that, we now completed our first lesson of the day. And what I'm going to tell you to do until here to the 12 noon, because at 12 noon we take our 1 hour break, is try some of the practice questions. Remember what I said about that? There's a lot of them, so the majority you're going to have to continue beyond the class and beyond this week. But at least I give you a head start and give you an insight to get familiar with that resource during the class there. But ultimately, you're going to have to do them, way beyond the class and beyond the week there. And just as a reminder, you have that in the CertMaster platform where it says the study version, not to be confused with the lab option. It's the one titled study. Let me find mine. Oh, it probably must be on the top. That's the labs version. Oh, there it is. Uh, I have all these because, I'm logged in as the instructor. So, you would hit the keep studying, right, under the CertMaster study version, not the labs. And then remember the outline option here. And all these, right, for all the topics we cover there. But each of them has their own section that says lesson review is the point. Right? I showed you that earlier too. Where, they give you a set of practice questions there that you could try to gauge where you are in your knowledge retention there. Now remember what I said, I'm giving you an opportunity to try these. Not that you could do them all during class, that because I would need to give too much time and I don't have that much time. That's why it says no time limit, because they figure you're going to do them outside of the class. And outside of the class, you have no time limit. Okay. In the class, I only give you X amount of time to get a head start in the process, but you're going to have to do the majority way beyond the class and way beyond this week to gauge where you are in your knowledge retention. And I always tell students, don't be hard on yourself initially. We cover a lot of information in each of these lessons, and odds are you're not going to remember everything in an instant unless you have an incredible memory in mind that you can remember things and not forget in an instant. Or these are review topics for you because you've been doing networking already, and I'm just reviewing stuff for you. Then you already have it in here. But if that's not your case, if you don't have an incredible mind that remembers everything in an instant, and you haven't been doing networking, odds are you're going to get wrong answers as you go along, right? You will hope to remember everything in an instant, but usually that's not the case. But by the wrong answers is your focus point. That's the way you got to look at it. It's a topic that you're eventually going to have to go back and review until you lock in that topic, because it's important to start locking in topics and not just answers. If you go about just memorizing answers, that's the wrong approach. Because by just memorizing answer and not knowing the topic is like saying, I'm going to see these questions again somewhere else. And I could tell you right now, that's the wrong thought, because these questions are not the questions from the exam, right? CompTIA would never do that. Anyone that gives you the questions before the exam, that's called cheating. And CompTIA doesn't cheat on itself. But what they do is a topic is a topic. If you know the topic, no matter how you see it in a question format, you should know that that's the answer because you know the topic. So that's what you ultimately have to lock in over time, these topics. There's a lot of topics, but that's their expectation there. The candidate needs to know these topics to be able to answer questions effectively on them. It does take time to lock in those topics, especially if these topics are new to you. But you're going to have to put in that time beyond the course and beyond this week there. Okay. Well, the expectation, you got to remember that whole model mode, right? They cover everything. You got to remember everything. I'm not gonna be the type that says, oh, forget about this and only emphasize. No, they show you the whole model. You got to know the whole model, right? Any information that they're showing you in the course, the expectation is you know those topics there, right? I'm not going to say, only learn the first five and forget I'm not going to say that. You got to know it all. Whatever they show in the courses, they expect a candidate to know. Okay. That's the way you got to look at it. Okay. Yeah. Oh, I'm sorry. I thought you meant for, well, yeah, the OSI model is about troubleshooting. Like they showed you, if you suspect it's software, then you're dealing with the upper layers. If you suspect it's a hardware issue, then you're dealing with the lower layers. That's the way we reference it for troubleshooting, in the real world there. Because you got to relate, switches operate at the data link layer, routers operate at the IP layer and so forth. That's the way you relate hardware, software related issues there. I'm sorry. I thought you meant for the exam. All right. All right, so yeah, from here to 12 noon, you'll try some of these questions. Again, the majority you're going to have to do off class time, but at least I give you a head start in getting familiar with how to launch these questions for yourselves, okay? And then off class, you'll have the no time limit at that point, right? Keep trying them beyond the class, beyond this week. All right, so that's your task from here to 12 noon. And then at 12 noon, I'm going to set the 1 hour clock, okay? Everybody's cool with getting to this point of launching those questions? Everybody's cool with that? All right, you got to be in the CertMaster platform, okay? Got to expand. You got to click on the keep studying. You got to expand the topics to get to those review questions. Okay. I only saw 2 people give me a thumbs up. Okay. I hope the rest of you are cool with it. How I got here. I'll show you how to get here. Okay. All right. Very good. See more people react now. Okay. I don't know. I'm still a little up in the air because I didn't get everybody showing me a thumbs up. Yes. Again, back where it says, right, cert mat, keep studying, right? You got to click select that. And then from there, you expand the lesson, and then you see all the individual topics, and then you the last option there is the questions. Okay. All right. All right. So that's your task. 12 o'clock, I set the 1 hour break. This is not a break period. Take the opportunity to get familiar with launching those questions for yourselves. Okay. So you can use that resource beyond the week and beyond the class. Okay. It's to help gauge where you are in your knowledge retention of the topics. Okay. Don't be hard on yourself. An incorrect answer just means it's a topic you got to review again. Okay. During your own self review time. Well, hey, just going back to what you mentioned earlier. Yeah, during my time in the field, we used to use the layers all the time. We used to say, "Oh, that's a layer one problem," meaning that it's a physical issue. That's a physical layer, like a bad cable or something. So we used to use the OSI reference all the time in troubleshooting. Yeah. Oh, that's a switch problem. Oh, that's layer two. The switches operate at layer two. That's the way we used to relate it. Yeah. Oh, absolutely. Oh, definitely. Yeah. That's the jargon of the industry per se. People that are in the industry relate things like that. You may never hear someone relate things like that, but we did that all the time when I was in the field. Yeah. It's like, oh, another layer one. Uh-oh. They put the wrong IP address. That's that layer three issue. Yeah. So yeah. Yeah, like if someone tells you, hey, I think that's a layer three problem, you should know, oh, it's IP related. You follow me, right? That's the way we relate it there. By the way, FYI, of course, to use these CompTIA resources beyond the class, beyond the week, you don't have to be in the class to do that, right? You just go right to their Cert Master Platform website, the CompTIA site, right? Because you don't launch it from the MyGK portal anyway. All you do in the MyGK portal is launch to get into the virtual class, which I show you. Well, I mentioned there's an alternative to the Zoom, right? You could get into the Zoom too. But yeah, these resources from CompTIA, you go right to their site to launch it, right? Beyond the class, beyond this week. Okay, well, I'm going to set a 1 hour break timer now. All right, 60 minutes. I'll see you back in 60 minutes. Just an FYI, during the break, I usually am away from my laptop because I go upstairs to my kitchen area and so forth. I'm not, staring at the timer all the time, just in case you're trying to get my attention. But I usually come back about 15 minutes or so before the timer ends. Okay, just an FYI. Okay, all welcome back. It was a 1 hour break. All right, what I want to do before returning to lecture is I want you all to get familiar with another resource you have access to from CompTIA. Right, I let you try the getting familiar with the launching the practice questions earlier today. The other resource you have access to from the Cert Master is their lab environment. Now, I mentioned previously that. What happened here? Hold on. I'm sorry, my Zoom just got locked up here. Hold on. Huh. I don't know. My Zoom is going to drop off here. Hold on. I'm trying something and it just locked up on me. Hmm. Ah. All right, I'm back. Zoom locked up on me for some reason and dropped me off. All right, so I was saying I want you to get familiar with the other resource that CompTIA gives you access to, which is the lab environment as well. I was saying this morning, like the practice question, the majority of labs you have to do off class and beyond this week because, for each lesson they give like an hour worth of labs for each lesson. So I can't allocate 3 hours of lab time a day. I won't have a time for lecture. But I want you to get familiar with using that resource. So I'm going to demonstrate the first one and then have you try it. Everyone should be seeing my second window. Now, one thing about launching the labs is you need a large enough monitor. If you're trying to use a small laptop monitor, it probably won't launch on you. It requires a larger monitor for larger resolution. That's their requirement. Okay, little FYI. But if you have a large enough monitor where it says Network Plus or Master Labs, you select the Keep Studying. Then, similar to the lesson side, you have an outline here that breaks down all the lessons, and then each of them offered different labs for each lesson there. And I'm going to launch this create a network topology one over here. Now, again, if you have a large enough monitor, it will offer start. If you don't, it'll tell you that your resolution is not large enough, right? That's just their requirement there, okay? Matter of fact, I'll show you what I'm talking about. I'm going to watch. I'm going to move this same window to my laptop window. And you will see that now the start is grayed out. I can't launch it because the laptop window is too small of a resolution. It says content is only available on larger screens. All right, just a little FYI, you would need a larger window to launch the those labs, okay? All right, but I'm going to launch that first one. I have a second monitor attached to my laptop. And they launch a new window. And there it is. And it tells you what you need to do on the left there. It says in this lab, you're tasked to create a network design by doing the following: move marketing's 5 computers in their switch to the canvas and connect the devices to create a star topology. Remember the star topology from earlier there? And then you see below the canvas, you have options there, end devices, you have switch there, you have router there, you have create links. Now I'm going to drag in some end devices here. Well, you click on it, then it shows the 5 marketing, and then I drag them into the canvas here. All right, so that's done. But now it wants me to create a star topology, right? Remember, a star topology has a central device that everything then connects to. Well, we have a switch to do that. All right, click that. It says marketing switch. So I bring the switch in here. Now I just got to make a connection, right, from the marketing workstations to one of the switch ports. So that's where this link icon works out. It says select a node in a diagram to connect. You click that one, you hit the Ethernet there, and then you click on the switch and it tells you, okay, select one of the ports to connect. All right, port 0. There you go. Made one connection there. Do the same for this one, Ethernet. Use another port 1. All right, creating a star topology, connecting them to the physical switch. I mean, to the switch, entry point switch. All right, that should do it. All right, now I got the marketing endpoints connected to the central switch in a star topology there. And then on the top right, it says check answers. So let me see if I did it right. And it says I score 100% because I created a star topology there, right? I connected the endpoint user devices to the central switch to create a star topology there. Okay. All right, so I want you to get familiar with doing the same, launching that same lab and getting familiar with the connectivity of these labs there. Again, the majority of them you're going to have to do way beyond the class and way beyond this week because there's hours and hours worth of labs for each of the lessons there. Okay, but at least I want you to get, starting point during class and get familiar with navigating the lab environment there. I'm going to allocate to 1:30 p.m. Eastern Standard Time for you to try the lab I just did there. That should be more than enough time to do that. And then at 1:30, I'll be returning to lecturing at that point. All right, so try out the lab. Again, the only issue is if you didn't have a larger enough monitor, that will be an issue. Its requirement needs a larger monitor. How's everyone doing with that star topology lab? Has anyone completed it? Okay, Nicholas, you completed. Okay, Trey has too. All right, very good, James. There you go. Yeah. If you wanted to try another one, because I've allocated to 130, if you, as long as you have time, especially if you completed the first one and pretty fast. The 1.4 version is similar. Create a Soho network. You could try that one too. Okay, but that's only if you've already done the first one at this point. Because if you're still working on the first one and it's 128, I'm not going to allocate. I'm not going to say do the other one because again, my time is up to 130. I have to begin lecture at that time. Okay. But if you have time, yeah, try the 1.4. It's a similar, creating a Soho network. And then they have you test connectivity with ping and stuff like that. All right, we reached 1:30. I'm going to continue now with our lecture objective. Again, we should be doing the 3 lessons a day. So for the remainder of the day, we're going to be covering lesson 2 and 3. All right, we covered lesson 1 this morning. All right. So again, that was, to give you an opportunity to get acclimated to the other resource that CompTIA provides you besides the review questions there, which again, you use beyond the class and beyond this week there. I'll give you some other opportunities throughout this week, but again, never to the point where you could do all the labs through the week. I will have to give you like 3 hours a day, and I can't do that in an 8-hour day. So the majority you're going to have to do off class and beyond this week. All right, so new topic here, module 2 is supporting cabling and physical installations. And let's see, for this particular section, we have 6 topic sections to cover. First up, lesson 2.1 refers to an Ethernet reference. Now, Ethernet is actually a data link, layer 2 reference there. Ethernet is a media access control operating at layer 2. Ethernet was actually developed by 3 organizations, Digital, Intel, and Xerox, especially accredited to Xerox there. But Ethernet, when it was introduced to the market, was introduced to become a standard under the IEEE organization. The IEEE organization develops, and the IEEE is referenced in your student guide, not on my slide. But the IEEE, the Institute of Electrical and Electronics Engineering, mentions in your guide, they developed the 802 standards there. Some would say because they came out in 1980 2nd month, but IEEE themselves says that's just the next standard value that they chose. But after the 802 is dot, then a numerical number, and in particular for Ethernet is 802.3 that they mention in your guide there. But after the 3, they'll have a small case lettering to designate the different types of Ethernet standards that have been developed throughout the years there. But one of the factors and why they're mentioning Ethernet standards is, even though Ethernet is a layer 2 reference itself, but it's depending on the Ethernet standard, what type of media will you deploy? The media side, like the cabling, is the layer 1, it's the physical layer reference there, whether it be a twisted pair cabling or fiber optics there, or even running it across wireless transmissions there. Right, but you have to have the proper cabling depending on the Ethernet standard there, right? So that's why they're referencing back to Ethernet at this point. Yeah, and when they improve Ethernet technology over the years, it increased the speeds, like they mentioned, from 100 base TX. 100 is 100 megabits per second. Base is baseband signaling, where the bits go out in a serial one after the other there, because you have broadband where you got more than one transmission go out simultaneously. The TX is twisted pair at full duplex mode. That's what 100 base TX means there. But then they developed, gigabit technology. Gigabit came out in 1999. But the factor is, you had to have the right category cabling in the twisted pair side to support the gigabit standard and the higher speeds of transmission there across the wire, across the physical layer. And then they also, develop Ethernet to run across fiber connections as well, using fiber optics to transmit the bits as patterns of zeros and ones, right, at high speed to long destinations there or further destinations there. Now here they mention network data transmissions there, but there's a reference in your guides. Well, we're going to see it coming up as we go along. We have the network data transmission. Says data transfer modulates mediums, whether it be electrical currents or light going across fiber optics or going across the radio frequencies, right? The wider size radio waves there. And it says higher frequencies equal more data transfer or bandwidth there. And the bandwidth, it says data transfer capacity measured in hertz. Hertz is 1 cycle per second. Or we have the reference of BPS, bits per second. Yeah, and the newer Ethernet standards, that's what you get higher. The higher bits per second. Like 1,000. A meg is, 1,000 million is a billion, or you could say 1 gig though. But they'll express it as 1,000 bits per second. 1,000 million is a 1 gig, 1 billion per second there. And that's the range that we have reached now, that we're transmitting things at billions per second. Actually, we've even exceeded billions there. We're even doing trillions of bits at the very high billions of bits per second. They start referring to it as trillions of bits per second at that point. And so, the Ethernet standards have been developed throughout the years there. And the improvement of the technology increased the speeds going from one Ethernet standard to the other there. And yeah, I gave you the breakdown earlier. If you see something like X base Y, the X is the speed involved. Base is baseband signaling, the bits going out one after the other across the wire. And it could be a different medium, twisted pair. It could be a fiber, even coaxial there. And that is utilized as the physical layer medium there. Yeah, copper is still very popular in its use there. That was origins, doing the electrical transmission across the copper there. Of course, fiber has gained a lot of ground, but we still, especially on the land side, we still see a lot of copper being used on the land side there. I mean, you could use fiber on the land too, but fiber definitely used a lot out on the WAN side, the wide area network there. And then this next reference, and this is related to Ethernet. Again, Ethernet is a media access control that operates at layer 2 data link there. And when they develop Ethernet, they develop what they call carrier sense multiple access with collision detection there. The carrier sense multiple access device that wants to transmit its data onto the network, onto the wire. It says, data to transmit. It checks the network, make sure nothing else is transmitting at the at that moment. Nothing else transmitting at the moment. It starts transmitting its data. The only thing is, in its origins, Ethernet was introduced operating at half duplex mode because in its origins we used a lot of hubs, and hubs only operated at half duplex, meaning that devices can only transmit and receive one at a time, and that allowed for more collisions where different signals met on the wire. Like if a device was transmitting and then receiving, it receives something at the same time at half duplex mode, those signals would collide there. But then, that's why they developed the CD portion of Ethernet collision detection. So if a collision is detected, the system waits for a random period of time to then try to retransmit to avoid collisions there. Right. So that's, the carrier sense multiple access with collision detection that Ethernet provides going across the wire. Although, you fast forward to modern times, now we communicate with full duplex like switches, could transmit out the device to transmit and receive at the same time. And that pretty much eliminated collisions once that happened, FY. Although they still develop it with the collision detection. Hmm. Okay, here and then, they're expressing Ethernet standards. Yeah, back when we have 100 megabits per second, that was considered for its time, fast Ethernet. We're talking about late 80s, 90s time frame, 100 megabits. And during that time, we started seeing hubs replaced with switches as well there. And again, as I said, the switches operate in full duplex, allowing the device transmit and receive at the same time, where hubs will only have duplex there, which pretty much eliminated the collision factor on the networks there. But you had to use the right category cabling. In the twisted pair, there's different category cabling. And they say, category 5 cable in particular, that supports 100 megabits at 100 meters maximum length before the signal, weakens or attenuates there. And then auto negotiation also, especially between the switch and the endpoint device, because they have to use the same speed on both ends, from the switch port to the NIC card, and the same duplex. The switch should be able to match, the 100 megabits and full duplex mode, as long as the endpoint client has the right NIC card to support that on its end, deployed with the right Ethernet standard for 100 megabits per second. And then they introduced gigabit. Gigabit was introduced back in 1999. I remember because I was still in the field there. And that's 1,000 megabits per second is 1 gig there. And that became much higher speed, right? Higher than the 100 megabits. And all the customers wanted it. They say, I want to go from the 100 meg to the gig. But we had to tell the customer, the requirements there. Before, they're not mentioning just the 1 gig because they're showing 10 and 4 gig because that's the evolution, as the technology improves. But at the 1 gig, there had to have been a minimum of category 5E in particular. They mentioned that in your guide reference. They mentioned 5E as the enhanced version instead of just category 5 because that handled the higher bits and the higher hertz traveling across the cable there. And so we had to tell customers that, well, we're on Cat 5 right now. We need Cat 5E, to support the gigabit Ethernet. And then, everything had to be retrofitted. The endpoint device had to have a NIC card that supported. Your switch had to support it, to get the higher speeds. Now, they're mentioning 10 gig base T there. They're showing unshielded twisted pair category 6 cabling, or full unshielded twisted pair, shielded for twisted pair, even going up to the category 7 there. And they're showing, maximum, there's a 6A augmented. Yeah, because category 6 for 10 gig, it does 55 meters, 180 feet. The 6A gives you up to 100 meters, 328 feet. Category 7 does 100 meters, 120 feet. Category 7 is always shielded. There's an additional shielding around each twisted pair when you strip back the jacket of the cable there. And then they mentioned also 40 gig shielded full twisted pair category 8 cabling you would need there. It's for short distance, like, ideal for data center environments at higher speeds, equipment talking like switch to switch communications at the higher speeds there in the data center, using category 8 cabling to do it. Anyone been exposed to working with twisted pair category cabling by chance? I'm just curious there. When I say working with it, like maybe, installing it, deploying it. All right, some of you have that exposure. Yeah. I was in the field. We did that a lot. Ran a lot of cabling for the customers there. Here they're showing, the fiber optic side. So, you could run the Ethernet across fiber there. Of course, fiber is the light now, right? Instead of electrical signal there. And there's a multi-mode fiber for shorter distance there. And there's single mode fiber for long distance, like, kilometers or miles of distance before the light weakens there. And so, they're showing the different specification, the optics, the cable, the maximum distance, and the connectors for the fiber on the right there. So yeah, you can run Ethernet across copper or fiber. Again, I said the fiber is popular, especially on the WAN side, where copper is still popular on the LAN side there. And, I mean, you can have fiber on the LAN too, and that's done also. But I'm saying, like, usually if you're gonna have a wire connection, there'll be an RJ45 wall port, and you have the user put in the twisted pair cable into the wall port that leads back to a patch panel that leads to a switch port ultimately there, right, for wire connection there, but patch cable they call it from the patch panel. Where long distance or in between buildings, like in a campus, we use multi-mode fiber. If we to a metropolitan area networks, we use single mode fiber, connect different locations at long distances to each other, right, across fiber links, and send the Ethernet across that. All right, so that completes 2.1, but it continues with more cabling, 2.2 copper cables and connectors. right? Copper is still popular there. And so they mention copper cables connected and connectors there. Now you have the unshielded twisted pair. Yeah, because when you pull back the jacket, you'll see the twisted pairs, but no additional shielding around them. They show a picture in your student guide. It's not on my slide, right? That's unshielded twisted pair. You strip back the jacket, it shows the color-coded twisted pair without any additional shielding around them. That's why I call it unshielded twisted pair. And unshielded twisted pair is still very popular in use there. But without the additional shielding, you got to be careful that you don't run it close to sources of EMI, electromagnetic interference there, where another electrical signal could be introduced into the wire because that's going to affect transmissions there. Yeah, like when we used to run them, we used to run them away from motors, away from fluorescent lighting has the balances that give off a lot of EMI. So you had to run them further up or further away. So, the EMI doesn't hit the cable because it's not shielded there, right? It's just the pairs underneath that jacket. That jacket is not enough shielding there. And and then, there's different categories from one category to the other. It says twist rates, reduce external interference and crosstalk. That's why the pairs are twisted amongst themselves there, all right, and color coded because they create a balanced pair. They call that. They eliminate the EMI between themselves there. But they mentioned it says twisted pair can use either solid or stranded conductor wires. It says solid cabling uses a single fake wire per conductor and is used for cables that run behind walls or through ducts. It says where the stranded cabling uses thin filament wires wrap around one another and is used to make flexible patch cords for connecting computers to wall jacks and switch ports to patch panels. It says copper wire thickness is measured using American wire gauge, AWG. It says increasing AWG numbers represent thinner wires. A lot of cables use thicker 22 or 24 AWG, while the stranded cable use for patch cords use 26. Yeah, the higher number, the thinner the copper there in the AWG reference there. They mentioned the AWG in your guide reference. It's not on my slide. Okay. American wire gauge there. But you have again the unshielded, right? As I showed you in that picture, right? You strip back the jacket, no additional shielding around each of the pairs. That's unshielded twisted pair. But then you do, oops, sorry. But then you do have the shielded version and screen twisted pair that has an additional shielding around each pair. As a matter of fact, category 7 always comes shielded. If I show you a category 7 reference, Cat 7, is always a shielded cable. You see the additional shielding right there. See it? Matter of fact, this picture does a comparison. You could have shielding around other categories besides 7, but 7 always comes shielded there. It's made to be shielded. There's an additional shielding around each of the pairs there to further contain, the signal within the pairs and to try to prevent external signals from entering the pairs. Right? Oh, I didn't mean to click on that. Right, that's the additional shielding there. Okay, shielded twisted pair. Additional foil you see around the twisted pairs of shielding there. That's sometimes known as foil outer shield, right? You see the additional foil around each pair there. That's the shielding. Yeah, especially if you're going to run it in areas with a lot of sources of EMI, like near motors and so forth, then you want the additional shielding in that regard there. And that would be preferred, opposed to the unshielded twisted pair version there. And then here, this is a good reference here because it mentions all the category types and their characteristics there. Yeah. It says, the category and the class, reference, cable type, Ethernet standard supports, and maximum distance, and the frequency that could run through the cable there. They have again, if you're following along with the guide, you have the same reference in your guides. Remember what I said, right? You follow along your guide, you see the same references in your guides, okay? Right, when you're following along there. Remember, sometimes there'll be things in the guides that are not on my slide, but I point them out anyway. Okay? But yeah, there's a good reference because besides the category, which is, the standards that were created, the organization that created the standards for the categories is the ANSI, American National Standards Institute, and also TIA, the Telecommunication Industry Association, and also EIA was formed, Electronic Industry Alliance there, right? The TIA, EIA, along with ANSI created these type of standards that are utilized there. And they came out with the category references and the class reference too. So Cat 5E is Class D, 6 is Class E, 6A is Class EA, 7 is Class F. Although technically 7 is not part of their direct standards because there's a Category 7 in the European standards too, by the way. So technically Cat 7 is not referenced under the TIAEI because it's also a European standard, Category 7. No, that's why I mentioned that. And then the Cat A and A.1, Class I, and A.2, Class I. So and they reference, if it comes unshielded or full twisted pair, right, with additional shielding. But what's important to know also what Ethernet standard they support in terms of the speed. And that's the difference there. But even how they manufacture is the twist ratio and how they manufacture one category to the other. And you could actually see that difference there. Uh, Let me see, Cat 5e and Cat 6. I just want to bring up a comparison of you see an image. Yeah, let's see if we could probably notice here. If you look carefully, you can see the twist ratio is different. Look at the category 6 and how tight those twists are in the cabling. See it? And look at the 5E. It still has twists, but not as tight as the category 6. They do that, the more twist ratio for the higher speeds to try to balance out the cable more, right? So that the signal doesn't bleed from one pair to the other. They twist it more. So yeah, how they manufacture is a big factor. But that's why you always need the right category depending on the Ethernet standard. You can't just say, oh, we're going to go to 10 gig. Let's keep the 5E. No, it doesn't have enough twist ratio to contain the higher speed that 10 gig does. The category 6 does that instead, right? With the tighter twist ratio. So it does matter. Yeah. Going from one category to the other, the way they manufacture them with the twist ratio to contain the higher hertz and the higher speeds of the Ethernet standard. So it really does matter. And that's why, when customers wanted to go from one Ethernet standard to the other, we had to address the cabling, depending on what they were using there, right, and what Ethernet standard they wanted. So it does make a difference. All right, continuing here. And then they mentioned, the connectors involved in twisted pair, the very popular RJ45 is shown there, right? Oh, excuse me. Yeah, the RJ45 accommodates the 4 pairs and the 8 positions or 8 contacts there. But there's, color coding standard that's followed. We're going to see that coming up. Then you have the former RJ11 we used to use back in the day. It says RJ11 connector can support 6 position, but only the center 2 contacts are wired. In a telephone system, this pair carries the dial tone voice circuits. So yeah, we used that for telephony back in the day, the RJ11 there. Anyone seen an RJ11 recently by chance? It's old school telephony. Yeah, okay, Trey has. Yeah. I still, believe it or not, I still have plain old telephone service besides my cell phone. I kept my POTS line. Yeah, I kept it. And yeah, RJ11 connection plugged in, boom, into the wall jack there. Yeah, old school telephony. Yeah, even digital PBXs use the RJ11 because they weren't VoIP. Yeah, they weren't going across the LAN. All right, this next reference is plenum and riser rated cable. Yeah, plenum conduits that are used in a physical environment. It says, plenum space is a void in a building designed to carry heating, ventilation, air conditioning. It says plenum space typically a false ceiling, though it could also be constructed as a raised floor. It says, as it makes installation simpler, this space has also been used for communication wiring in some building design. Absolutely, yeah, we used to run the cabling to the plenum conduit from points there. But you had to use plenum rated cabling to do it, buying by fire codes, because plenum rated cabling it says, fire retardant, plenum cable, because if they burn, they don't burn toxic there, and they're more fire resistant. Because if you did a PVC through plenum, that would violate fire codes. PVC is phenyl vinyl chloride, which if FEP, if those burn, FEP is fluorinated ethylene propylene. That just the name sounds harmful. But if they burn, yeah, they burn toxic, and then that toxic fumes will be spread through the plenum conduit. That would be a big problem there, right? So yeah, you got to get plenum rated cabling to run through plenum conduits. Then you have riser cabling. And riser cabling goes between floors, right? Rising between floors. And same thing, they had to be rated to do that, right? For fire codes and regulations there. It says must be fire stop, because you got to bore holes between the floors, but then you have to seal it thoroughly and so forth to conform to the fire regulations of buildings there. All right, it says confirm to fire safety. Yeah, you don't want the fire spreading through the cabling there from one floor to the other there. And it says, riser rated cable marked with CMR there. The specially made cabling to address the fire codes when you're running it in the physical environment, dependent spaces or between floors there. You had to accommodate, because they weren't doing inspections. If they didn't have the right cabling, that would violate fire codes. That would be a big problem. Okay, also under the copper category is coaxial. Coaxial, yeah, could still be used in some instances. I had back in the day, I had cable TV, right? How many of you had cable TV back in the day? I say back in the day because, I mean, you can still have it, but honestly, everybody's streaming, right? Everything's a stream now. So, which is what I'm doing now, where I'm streaming everything. But yeah, back in the day, I had cable TV, but then I also had cable modem, cable internet. And so I had coaxial in my home because of that. That's why I'm mentioning it, right? They brought coaxial in my home. And yeah, but even in the field days, I used to run coaxial for CCTVs, closed circuit television use coax. I used to run them way back in the day for even LAN installation, like in the bus topology that they mentioned earlier. You used to coax for that, like a daisy chain. So yeah, coaxial copper is it says made of 2 conductors that share the same axis, coaxial, right? It says the core conductor is made of a solid or stranded copper wire and is enclosed by plastic insulation. It says a wire mesh wrapped around the plastic constitutes the second conductor. So it serves as a shielding for interference there. Yes, that's coaxial cabling. Yeah, they mentioned there's radio grades they're rated at, radio grade designations for coaxial, which represent the thickness of the core conductor and the cable's characteristics. As the radio grade 6 18 AWG cable with 75 ohm impedance, typically used as drop cable for cable access TV, which I had back in the day, and broadband cable modem, which I also had. And then there's the thinner, more flexible RG59. It says used for audio, video, and closed circuit television, which I used to run for customers when I was in the field back in the day. And then you have the connectors for the coaxial. They mentioned the BNC type connector, which has a twist and lock function to it, and then or the F type connector, which is a screw-on connector there for the coaxial. And then you have twin axle cabling. Twin axle cabling is popular in data center environments there. I don't know if anyone ever seen that twin axle in a data center environment before. They're meant for, the higher speeds of gigabit, the twin axle on the right there. It says twin ax. So it says similar to coax, but contains two inner conductors. It says twin ax is used for data center interconnects working at 10 gigabits, unofficially referred to as 10G base CR, and 40 gigabits Ethernet also, or 40G base CR4. It says the maximum distance is about 5 meters. So, it's for shorter connections of the equipment within the data center environment. It says for passive cable types and 10 meters for active. It says twin ax 1040 gigabit Ethernet is terminated using direct attached copper transceivers that you see at the ends there. It says these transceivers can be installed as modulars. Remember, transceivers transmitting and receiving the signal. It says in switches, routers, or server appliances there. Yeah, so twin ax and data centers to connect switches, routers, server appliances. Yeah. All right, so that was the copper stuff there, right? Which is still very popular in network environments. We'll take a 10-minute break and then I'll continue. Right off, 10-minute break. Okay, so now we're into lesson 2.3, which is wiring implementation topics. So here we're going to cover the structure of cabling systems. Again, the standards for termination. They refer to patch panel, structure cable, termination tool, and techniques there. So the first reference here, that refers to structured cabling systems. We have a work area there where, the users, for example, plug in their endpoint systems in the work area. It says, space where user equipment is located and connected to a network, usually via patch cable plug into a wall jack. Then you have the horizontal cabling, the literal twisted pair cabling runs that are made from the work area to a IDF location, which is known as intermediate distribution frame, or the local wiring closet or telecommunications room there, where the cabling ultimately gets terminated into there. Right, once you run the horizontal runs to the telecommunications room or the wiring closets there. And then they mentioned the backbone cabling. It says connects the intermediate distribution frame to a main distribution frame where the main equipment is. It says backbone cabling is also referred to as vertical cabling, as it's more likely to run up and down between floors there. And then you have entrance facilities and points of demarcation, the demarc point. Yeah, especially as circuits are brought into and organizations building facilities there. It says, the demarcation point is where the access provider network terminates, the organizations and networks begin. Yeah, during my time in the field, that's what we did. We brought our WAN circuits into a building and brought it to the point of demarcation within that building, wherever that was designated. And then, hand off the circuit to the customer. And we used to provide a demarc there. Like when I was installing T1s, it was called a smart jack or PRI. And then, beyond that, it wired into the customer provided equipment there. That kind of determined responsibility if something happened. We used to do loopback testing where you send a signal to see if it comes right back to you. And that's why we used to install a smart jack at the point of demarcation. Because if there was a problem with the circuit, we used to send a loopback signal. If it reached the smart jack, it would send it back to us. So we knew our signal was reaching all the way to the point of demarcation. Beyond that point, if we didn't manage it, was the customer equipment. We would tell them, well, we tested good to our point of demarc. Beyond that is your equipment. If you still want us to come out, it might be billable time. Because if we're not responsible for your customer equipment side and that ends up being the problem, we would have to bill for that there. Sometimes, we were managed service and we would take care of the equipment beyond the point of demarc too. We would take care of the customer equipment also. But it depends on the scenario. But that kind of makes the responsibility factor. Who is responsible to address an issue there. Up to the point of demarc there. Beyond that is the custom equipment. Up to that point is the provider circuits there, into the building. All right, next reference is following the TIA EIA color standards. The T56A was developed for the twisted pair and the color-coded twisted pair, and the T68B. And the difference between the pairs, A and B version, if you look carefully, is pins 1, 2, 3, and 6 are the difference. And they do that intentionally because pins 1, 2, 3, and 6 deal with transmit and receive pairs, because that's what the color coding designate, which pair is going to be used for what. And those particular 4 pairs are used for transmit and receive there. And they intentionally wire them the inverse of each other. This one's using the green, white, and white, green, and this one's using the orange, white, and right pairs. And then you can see that it changes, right? They flip them, the inverse there. Right? And they do that intentionally there. Because it depends what you're going to connect. Most modern equipment only need a straight through cable, meaning that both standards are wired the same on both ends, like A to A, B to B, straight through. Because if you do on one end A and the other end B, that's called a crossover cable because it crosses transmit and receive pairs. And in the past, some equipment needed that. Like in the past, like when you connect a switch to switch or router to router and you was using twisted pair, if the switch couldn't do what they call MDIX, medium dependent interface electronic crossover, because when switches connect, one side's transmit has to go to the other side's receive. Right? If the device is going to do that electronically, whether it be a switch, a router, even NIC cards, then you had to do it physically with a crossover cable, and it would be a cable wire with A on one side and B on the other to cross pins 1, 2, 3, and 6 for transmit and receive. But in modern times, you rarely need that. So in modern times, it's usually straight through, A to A, B to B, nothing cross between pins 1, 2, 3, and 6. But that's how they developed the two different standards on purpose that way, just in case you do need a crossover cable. That's how you wire it. And then here, everything, those horizontal runs from the work areas terminating to the patch panel points there. It says, cable management techniques and tools ensure the cabling is reliable and easy to maintain. Structured copper wiring runs from a wall port and the user work areas to some type of distribution frame. It says at both points it's terminated on a punch down block with installation displacement connection IDC terminals here. Yeah, the IDC terminals are like look like little copper claws in a sense, and then the wire pinches right between those, right, to make the connection there to connect the point on the patch panel. And same thing, you wire it to the back of the patch panel that way from the RJ45 wall port. But then on the front of the patch panel is the RJ45 connector where you put a patch cable into, and they show it in the picture in the guide here. There's the back, right, terminating on the punch down block with a punch down two, and then the front, the RJ45 with a patch cord going into a switch port, right, to make that wire connection. And here they mention structured cabling installation, things like, pulling the cable and finding the path that you're going to pull the cable through there. and then labeling both sides. Yeah, you should be able to go to a wall jack, look at the label, and then go to the patch panel and see the same value of the label. Then you know that's the cable from end to end there. And they mentioned even providing a service loop there. Some additional slack on the cable refers to service loop that you leave there on purpose there, just in case you need to cut things and terminate again there. And then you have to have the right type of tools there. Yeah, and some of the tools that are used as an electrician, scissors, nibs, are designed for cutting copper wire and stripping insulation, and cable jackets as alternative. There are dedicated cable stripper tools that have replaced blades for different types of data cable types. This cable cutting blades should be rounded to preserve the wire geometry. So stripping tools should have the correct diameter to strip a cable jacket without damaging the insulation wire. Yeah, I used to carry all that in my toolkit there, right, to terminate and run those cables there. You have a punch down too that punches down into the blocks there so that it make contact with the IDC there. They show a picture of that here of the punch down too. Anyone ever use a punch down too for any reason there like that? Yeah, you terminate it there on the patch panel that way, or maybe into the right, James have. Yeah, not yet there. Yeah, and they had different blades because there was different punch down blocks. It was 66 blocks, it was 110 blocks, there was Biggs blocks. So you had different blades for that. I used to have one that was able to punch down all four pairs at once, especially when I was terminating them on the patch panel instead of having to do boom, boom, boom. And it was like boom, and go to the neck, boom, boom. I had the four blades to punch them all down at once now. Now, there's evolutions of that. There's patch panels that are pre-wired and everything. Makes it much simpler. But yeah, those are the tools of the trade that we carried around there. Mm. All right. Okay, now that was the copper side of things. Now we get into the fiber optic cables and connectors, right? Fiber has become very popular in use there, especially on the WAN side, although you definitely could use it on the LAN as well. Or even a CAN campus area network or metropolitan area network use a lot of fiber there. All right, so fiber optics there. And in the fiber optics, they describe the cable there. You have the core of a fiber optics. Now again, the fiber, of course, is carrying a light source instead of electrical signal there. And by the way, that's why the origins of fiber, because a light is not susceptible to the EMI factor, electromagnetic interference. That EMI affects electrical signals, right? It won't affect light that way there, right? Light is more intangible that way there. I mean, other things could affect the light, but not the EMI factor there. And also, light could travel a further distance when compared to electrical signal before it weakens there. Depending on the mode using, it could be kilometers, miles of distance before the signal weakens. And that's, big advantages over the electrical version there. And so they mentioned the core of the fiber. It says provides a transmission path for waveguide for the light signals. You have the cladding to keep the light into the cable. It says cladding reflects signals back into the waveguide as efficiently as possible. If not, the light will escape out, right? And then there's a buffer. It's a protective plastic coating in the fiber. It says there may be a tight or loose configuration with a loose format using some form of lubricant between the strand and the sheath there, right? That comprises the fiber optic cable there. And it mentions, operations and bundling that's done. Yeah, a lot of fiber are distributed as bundles for numerous strands of fiber right within the bundle. It says there are different outer jacket designs and materials also suited for different installation. You have indoor plenum, outdoor, underground, undersea. Well, the undersea, the ones that run across the ocean, they literally bury them in the ocean floor, to protect them further. You have Kevlar and aramid to strands, and sometimes fiberglass, rods, steel strength members is often used to protect the fibers from excessive bending or kinking when pulling the cable to install. It says for exposure outdoor applications, a steel shield armor may be added to deter rodents from going on the cable there. Yeah. Then you have the different modes that are used within fiber optics. They mentioned the single mode fiber. It says has a small core, 8 to 10 microns, and a long wavelength of light. So it uses a concentrated laser to generate near infrared light signal there. Yeah, but the single mode fiber is the one that could go, because of the high concentrated laser, could go kilometers, miles of distance before it weakens there. And it's a single wavelength of light right down to a small circumference core. But then you have multi-mode fibers. It says has a larger core and shorter wavelength of light and transmitted in multiple waves, hence multimode of varying lengths. Says multimode fiber uses less expensive optics and consequently is less expensive to deploy than single mode fiber. But multimode fiber is not intended for longer runs like the single mode there. Smaller distances, but still ideal. Like I mentioned, campus area networks. You have buildings in close proximity to each other. You can run, multimode fiber, or between floors, you can run multimode fibers, right? So, for the smaller distances when compared to single mode fiber. But then also within multimode, they have the OM reference there, the optical multimode. And depending on the OM level, the type of light source it will use. For the optical multimode 1 and 2, they mentioned it would use an LED as its light source, light emitting diode, which is a less expensive solution than laser. But again, that's not going to go, very far distances, right? But that is the preferred light source for OM1 and 2 deployments. Then you have the OM3 and 4. OM3 and 4 uses a specialized laser, not as concentrated as a single mode fiber. It says, specialized laser. They mentioned vertical cavity surface emitting laser that it uses, VC cell laser. It says it's not as powerful as a laser for the single mode fiber, but it supports higher modulation, transmitting light pulses rapidly than LED there. So yeah, but that's the specialized laser, right? That the BC cell laser that OM3 and 4 uses there. Not as concentrated as a single mode fiber laser, so still for shorter distances there. All right, so that's the option on the multi-mode fiber. And then you have the fiber optic connector types that are utilized there. They mention a straight tip. This is an earlier bayonet style connector that uses a push and twist locking mechanism, in the straight tip, the ST version. You have an SC version for fiber or subscriber cube that's utilized as a push and pull design, allowing for simple insertion and removal. So it can be used for single multi-mode, commonly used for gigabit Ethernet. And then you have an LC connector also is mentioned, right? Or known as local connector or Lucent connector. There's a small form factor connector. Yeah, and they do prefer that type of connector now, the small form factor, they call it. It's smaller in size, so smaller footprint. That means you got more port density on the equipment side because the ports are smaller to fit the smaller, small form factor pluggable connector that the LC provides there. And that is preferred now. It says LC is widely adapted for a form factor for gigabit Ethernet or 1040 gigabit Ethernet as well. Nice. That's various type of fiber connectors that are utilized. Then the next reference is the use of a fiber optic patch cords that are utilized there. And it says patch cables for fiber optics can come with the same connectors, like LC to LC, or you can mix them up. You got like an LC to SC. It says duplex patch cord must maintain the correct polarity, though. And that's important. I mentioned this earlier too. One side's transmit has to go to the other side's receive there. Think about it. That's the way we talk with each other. When you talk, you're transmitting. The other person is receiving it, right? Because if you turn the phone around, they're not going to hear you well because you're going to be talking on the right on the receive side. So it's always transmit and receive. Well, the same here, right? Signal has to go from transmit and receive there, and so they have to do that inversion there in the fiber optic patch cord stuff. Right, you see that one side receive heading to the other side's TX transmit, right? Transmit to the other side's receive there, right? The patch cord does that type of inversion there. Make sure the signals right go from transmit and receive on both ends there. All right, the next reference is the finishing types to attach, right, the connectors to the fiber there. And it says a core of a fiber optic connector is ceramic or plastic ferrule that holds the glass strand and ensures continuous receptions of the light signal. And then there's two operative types of finishing types for those connectors. You have a UPC version, ultra physical contact. It says the face of the connector and the fiber tips are polished so that they reduce back reflection, curve slightly, and fit together better. And you have an APC version, angle physical contact. It says the faces are angled for an even tighter connection. APC cannot be mixed with physical or ultra physical contact there. I only could work with APCs. Your guide shows a color coding that's not in my slide, but it's in your guide. This color coding because you could tell what type, depending on the jacket color and the connector color, what type of fiber. So like if the jacket color of the fiber is orange and the connector color is beige, then you're dealing with a OM1. Remember, OM is under the multimode fiber, right? We saw that earlier. If it's orange jacket and black connector, then an OM2. Now remember, OM1 and 2 are the ones that use the LED for the light source that was mentioned earlier, right? The light emitting diode. Then if it's an OM3 and 4, remember that's the one that used the VC cell, the specialized laser that's not as concentrated as the single mode. That's the OM3 and 4 on the multimode fiber. Its jacket color will be aqua and the connector color will be aqua, right, for OM3 and 4. And then if you're using single mode fiber, physical contact and ultra physical contact for the finishing type, right, to connect the connector to the fiber, then the jacket color will be yellow and the connector color will be blue. But if you're using single mode fiber, that's using the APC version, angle physical contact, which cannot be mixed with the physical and ultra physical contact, then its jacket color is yellow, but then its connector color is green there. So yeah, that's the color coding there to tell you what type of fiber is being deployed. And then next reference is fiber distribution panels that are utilized, right, to connect the fiber to equipment there. It says modern build refurbishment might replace copper wire with fiber optic cabling. It says structured cabling links are installed and matter similar to copper. It says, however, to avoid wear and tear, damage associated with continuing reconnecting fiber optics, it says essential not to frequently replace cable runs with conduits. It says permanent cables are therefore routed through conduits or wall ports, client access ends, into fiber distribution panels that they install, right, which ultimately then connects them to the equipment there. They show a nice picture of a fiber distribution channel in your student guide right here, right? Has anyone ever seen this type of fiber distribution channel by chance there? Just curious. Yeah, especially, you work in data center environments and so forth. You see a lot of this type of fiber connectivity in those type of environments there. Oh, Nicholas has, yeah. Yeah, and that's the fiber distribution channel. So use fiber patch cables to link wall port to NIC cards and patch panel to a switch port, but you're doing it through fiber, right? So that's the fiber distribution panels instead of copper. All right, and then we have multi-fiber push-on connectors or MPOs there. And it says allows for low footprint backbone or trunk cabling. It says cable bundles 12 or more strands terminated into a single compact ferrule, but there's multiple strands on a single compact ferrule, and they call those MPOs. Yeah, again, those are very popular, used in data center environments there. It says aggregates, they're prefabricated, not typically field terminated. It says aggregates 10 gigabits per second or 25 gigabit lanes into 40 gigabits, 100 and 400 gigabits parallel there. All right, that's the MPO. Let me bring up a visual aid on that. MPO fiber cable. Yeah, here. There's an example, Dell networking MPO breakout cable. Right, you can see each individual, right? Oh, breakout cable, multi-mode fiber OM 4 and 3 meters there, right? But you have the different connectors going into one MPO input there, right? Bridged out to different connectors for different connections there. All right, multi-fiber push-on connectors. Okay, then the next reference also related to fiber, and there's their own version. I showed the other one because you see the different connectors going into one input connector like that, right? The multi-fiber push-on connectors there. It spans out. All right, the next reference is the wavelength division multiplexing that's used. Yeah, and this is a technique because light has different wavelengths of light or frequencies of light. And we could use that to our advantage to send different wavelengths or frequency of light across the same fiber strand that don't interfere with each other there. And we did that all the time. So instead of having to have a one-to-one ratio of fiber strands for customers in a building going out to the WAN, we used to input them into a fiber mux multiplexer and use wave division multiplexing to transmit different customers into this across the same fiber optic cable, but at different wavelengths, at different frequencies that did not interfere with each other there. Yeah, just to give you a further insight how light has different wavelengths and frequencies. Like natively, we can't see an infrared spectrum, through our native eyes, but that's because that's a different wavelength frequency. Now we could use equipment to home in on that frequency of wavelength and then see the infrared spectrum, but natively we can't see that. I'm just giving you that insight that light has different wavelengths and different frequencies, and we could use that to our advantage to transmit those different wavelengths across the same fiber strand and they don't interfere with each other there. So that we could use the fiber strands more efficiently. We don't need a one-to-one ratio of every transmission and every receive there. We could go across the same fiber strand with different wavelengths there. And there's different versions of that. They mentioned the bidirectional wavelength division multiplexing there. It says support transmit receive signals over the same strand of fiber. Remember, transmit, right, to receive, but you use different wavelengths, one representing the transmit wavelength and one representing the receive wavelength. And then you could use the same fiber strand. You don't have to have a separate strand dedicated for transmit and another strand dedicated for receive. It could go across the same strand for different wavelengths, one indicating transmit, the other wavelength indicating receive. So that's bidirectional transceivers, uses bidirectional wavelength division multiplexing. Then there's a coarse wavelength division multiplexing. It says supports up to 16 wavelengths and it's typically used to deploy 4 or 8 bidirectional channels over either single fiber strand or unidirectional channels over dual fiber strands. One strand for transmit, the other strand for receive. But you still get multiple transmissions at different wavelengths across the same strands, just one dedicated for transmit, the other one dedicated for receive. Again, without doing this, you would need the one-to-one ratios of different strands for each transmissions going from different points there. But this one, you could go across the same fiber strands at different wavelengths. Then you have the very dense wavelength division multiplexing. It's a provision greater numbers of channels, 20, 40, 80, or 160. So this means that there is much less spacing between each channel, and it requires more precise and expensive lasers. It says the coarse and dense wavelength division multiplexing transceiver support multiple channels, 1 gig, 10 gig, 40 gigs. Ethernet link says the transceiver must be installed in opposite pairs there. Yeah, so that's, using the fiber strands more efficiently through wave division multiplexing, different wavelengths of light going across the same fiber strand that don't interfere with each other there. You could designate wavelengths for transmit and designate wavelengths for receive, and across the same fiber strands. All right, so with that now completes the fiber optic topic there. Lesson 2.5 gets into physical installation factors there. Okay. And so here, right, they're outlining physical installation factor topics there. They start off with the rack systems, right? Installing equipment in the racks there. It says networking equipment should be installed with secure areas. It says within a building, these can be referred to as telecommunication closets, equipment rooms, or server rooms there. It says a whole facility dedicated to provisioning service called a data center. Yeah, but in those environments, the racks are facilitated with the equipment. It says within telecommunication closets, server room, data centers, equipment stored in the racks. It says rack is especially configured steel shelving designed for standard size unit equipment there. But yeah, there's a unit size that they mentioned. It's the U units actually there. And one U unit is equal to 1.75 inches. They do mention that. Let me in your student guide reference there. It's not on my slide, but they mentioned right here. It says the rack height is measured in U units of 1.75 inches. Or if you convert it to centimeters, 4.45. It says racks are so in heights of 8 U's or 248 U's, which each U unit represents 1.75 inches there. The reason they do that is then you could lay out your equipment thoroughly. You measure the height of your equipment, and then your rack comes with X amount of U units, and then you can lay your equipment thoroughly, right? That would fit into that rack there, right? To the U unit reference there. You just multiply times 1.75 inch there, right? To get the total U units or inches that you could accommodate in the rack or centimeters. Then they mentioned in the rack cooling and airflow also has to be considered there. It says, rack-mounted appliances are usually designed with intake fans on the front to draw in cool air and exhaust fans on the back to expel warm air. It says some switch models can be configured between port side exhaust. It says where hot air is expelled on the same side as the port interface. It says port side and port side intake. It says port side intake allows a switch to be installed with ports facing the front of the rack, which might be better for some cabling management there, right? So you have to exhaust the intake the cold air and exhaust out the hot from the equipment there, right? Have proper airflow doing it. And then they also mentioned security features. Well, yeah, a lot of racks come with lockable racks there, right? It could be a key lock or biometrics lock and so forth for security features there. So people can just easily open the rack and take it. Now, even positioning the racks within the the environment, like the data center, you have to also, remove the heat within those racks of the equipment running. You have to control temperature and humidity there. And so organizations will use HVAC for that, right? The heating, ventilation, air conditioning in those rooms. So it's often used to describe these services, to uh, dissipate the cold air in the front of the rack, and then the hot air follows the cold air in the back of the rack, and then you vent that to your HVAC system, right? So it could go to the refrigeration cycle there. Also controlling humidity. Humidity is the amount of water vapor in the air. Excuse me. And you need, the right amount of water vapor in the air. Usually we say a 50% dead band where, 50% humidity. That means that you don't have, because if you have low humidity, low water vapor, it could lead to a lot of electrostatic discharge there, build up when you touch equipment that can damage it. Too much water vapor in the air will lead to condensation where the water forms on surfaces, right? And water tries to meet. So that's why you have to humidify and dehumidify, control that humidity, get a 50% amount of water vapor in the air is the ideal factor there. And that's usually built into the crack units, computer room air conditioning to humidify and dehumidify. And then, electrical factor, it says a computer system needs stable power, free from outages, power faders, voltage dips on the voltage and voltage spikes and surges there, right? So it doesn't damage equipment. And flooding, yeah, there could be flooding. A lot of data centers use raised floors. And there's flood strips that you could place on the raised floor. So if water touches the strips, it sets off an alarm and that right, that there's water underneath that raised floor and there's a flood there, right? You could